Namaskar, ma'am.
I welcome one and all present here. I welcome our Honorable Vice Chancellor, Professor Nirmala S. Maurya, ma'am. I from Veer Bahadur Singh Purvanchal University, Kanpur. I welcome our Vice Principal, ma'am, Dr. N.C. Rajashri, ma'am, from Guru Nanak College, Chennai, and all the participants, our resource person. We will start the program. Once I get a confirmation that we are going live, we'll just start off the program. Can you please, the room is full. If your friends are trying to join in, please inform them to use the YouTube link now, please.
Ma'am, the live has started.
Sorry, ma'am, you can start. The live stream is started.
Yes, sir. So, every program begins with the invocation to the Almighty for the success of the program. So, I request all of you to join in for the college prayer. Yes, can have been getting.
Good afternoon to all.
Good afternoon, ma'am. Good afternoon,
Yes,
ma'am.
Good afternoon. Good afternoon, madam.
सिख हो अपने ईमान को, लालच हो गुण तो चुरो, लालच हो गुण तो चुरो, लालच हो गुण तो चुरो, देह शिवा पर मोहे है, शुभ कर मन ते कब हो न डरूं, जब आग की आदन दान बने, जब आग की आदन दान बने, अधहीरन में तब जूझ मरो, अधहीरन में तब जूझ मरो, देह शिवा पर मोहे है, शुभ कर मन ते तब हो न डरूं, देह शिवा पर मोहे है, शुभ कर मन ते तब हो न डरूं, शुभ कर मन ते तब हो न डरूं, शुभ कर मन ते तब हो न डरूं.
I now request our Vice Principal, ma'am, Dr. N.C. Rajashri, to welcome the gathering. Ma'am.
Ma'am, unmute. Ma'am, unmute yourself, ma'am.
Namaste, everyone. Namaste to elders and my best wishes to all the youngsters who have joined this group and participate. I deem it a great pleasure to be here this afternoon. Always you come up with novel ideas, and this time with Purvanchal University's MOU, we are still more proactive, I should say. So thanks to the organizers who have well thought of program this is. So life science interface, the key to sustainability. Everywhere we have been talking about it. Now you want to share your views, and we have Professor Ram Narayan, Manoj Kumar Pandey sir is there. My biggest thanks and pranams to the Vice Chancellor, Madam Nirmala S. Maurya. Ma'am, with your blessings, we are going ahead, and I am sure this will benefit everybody. So on my behalf and on behalf of Purvanchal University also, I wish everyone a grand success. And not only that, I'm very happy to be here and to welcome every one of you, especially the Madam Chief Guest for the Presidential Address and Professor Ram Narayan sir, our team Mahendra Kumar, Dolly and Bharati Ravi Krishnan, Noorjahan Madam. So I'm really happy. I'm just walking through the yesteryear also. Last year we had, without a choice, we had to go with this. This year we wantonly want to do it this way so that it reaches more people. So my appreciations to you, Dolly, being the one-point contact and arranging such things, and all the resource persons who are going to be with us for the 5 days, who are going to share their thing. This is our common liability, this is our common responsibility, and this is our common accountability. Every one of us has a share to make it. So very nice of you to have chosen such a topic. I am also eagerly waiting like you all to hear to this. I welcome everybody from the bottom of the heart, and praying Almighty to shower all His blessings on all of us to see it through and much more. Welcome to one and all. Welcome once again. Thank you.
Thank you so much, ma'am. Thank you for all your blessings, all your best wishes, ma'am. Thank you. Now I would call upon the Dean of Sciences, Guru Nanak College, Dr. Noor Jahan, who was actually the mind behind this noble idea, ma'am, I should tell you. I had just told her we wanted to do something on life sciences, and she went ahead and gave us this idea, why not sustainability? So I would invite ma'am to explain the concept of this workshop. Ma'am.
Thank you, Dolly ma'am. Respected General Secretary and Correspondent Shri Manjit Singh Nair, ever motivating Principal Dr. M.G. Raghunathan, vibrant Vice Principal Dr. N.C. Rajshri Madam of Guru Nanak College, very enthusiastic and energetic Honorable Vice Chancellor of Veer Bahadur Singh Purvanchal University, Dr. Nirmala Maurya ji, respected Dean of Sciences from Purvanchal University, Professor Ram Narayan ji, then the resource persons of today's workshop, Dr. Bharati Ravi Krishnan, Head Department of Biotechnology, Guru Nanak College, and Professor Vandana Rai ji, former Dean and HOD Biotechnology, Purvanchal University, all the dignitaries, participants from various institutions throughout India, a warm good afternoon to all. I am here to explain about the importance of the topic of this workshop, life science interface, the key to sustainability. In the September 2015, 193 countries came together at the United Nations to adapt and commit to a long-term comprehensive strategy to tackle the world's greatest challenges related to global sustainable development. The result was the SDGs, that is the Sustainable Development Goals, a list of 17 goals to achieve a better and more sustainable future for all by 2030. This was the goal set by the UN, which is to be achieved by all of us together along with the global community. This workshop's objective is to create an awareness and to shed light on the areas, especially the interface between life science and other domains. Why the interface of the interdisciplinary approach is needed to achieve sustainability. The 3 R's, that is reduce, recycle, and reuse are the key ideas which will lead us to achieve the sustainability without further damaging our environment. We can implement the 3 R's effectively only when we work in this interface area. A material that is prepared for a particular application should be eco-friendly and should be green, meaning it should be biodegradable and recyclable. It should not leave any undesirable byproducts after its usage. This can be achieved only when other disciplines take the help of life sciences into their stream. Hope this workshop helps us to identify the key areas through which we can contribute to the Sustainable Development Goals. I thank Mrs. Dolly, Nodal Officer, Assistant Professor, Department of Hindi, Guru Nanak College, for initiating this workshop in collaboration with Veer Bahadur Singh Purvanchal University, Jaunpur, and Guru Nanak College, Chennai. Thank you for this opportunity. All the best to this workshop. Thank you.
Thank you so much, ma'am. Now, I would request the Dean of Sciences, Professor Ram Narayan Ji of Veer Bahadur Singh Purvanchal University, to present his viewpoints and explain the theme of the workshop. Sir.
Thank you very much, madam, and good afternoon to all of you. Honorable Vice Chancellor Professor Nirmala S. Maurya Ji, Vice Chancellor of Veer Bahadur Singh Purvanchal University, Dr. M.G. Raghunathan Ji, Principal of Guru Nanak College and Vice Principal of Guru Nanak College, and Dr. Dali, coordinator and organizer of the workshop, Dr. Manoj Kumar Pandey, Nodal Officer MOU BVS Purvanchal University, and several other responsible persons related to this 5-day workshop. I thank you and welcome to all of you. This particular 5-day workshop that is related to life science interface, the key to the sustainability. Well, we know that every sector of our life is related to the industrialization, and in each and every industry, every industry is producing a lot of pollutions, lot of effluents, which create instability. For example, agriculture sector or any industrial sector, that one is for its sustainability. So, well, nothing is to say, but for overcoming such type of problems, like emission of carbon dioxide in large amount and removal or biodegradation of different type of waste material released from such industries, they should be controlled within a time limit, as our government is thinking to make zero waste and zero emission up to 2050. So, well, the suggestions goes about such type of problems to get or to overcome from instability and to get sustainability to such type of problems. We have to select some specific and efficient type of plant varieties which will help in phytoremediation of plant materials. Similarly, we have to select novel microorganisms which could degrade pollutions and which could reduce the emission of carbon dioxide and methane gases, which creates a big greenhouse effect, and they have negative effect on our environment. Similarly, we have to avoid deforestation because deforestation is quite running very fastly. So forestation should be promoted and deforestation should be stopped. And in industries which are having very old age protocols or methods, they should also be improved to make industrialization advanced and improved. So all these things can be incorporated to overcome with such type of problems which are creating instability in our environment and in our every sector of our life. So thank you very much to all of you who have given me for this type of opportunity. Thank you very much.
Thank you, sir. I hope the concept and the theme of the workshop has been clear to the participants, and on the same lines, we'll be working 5 days for this online workshop. Also, our IQSC coordinator for Guru Nanak College, Dr. Swati Paliwal, Head and Dean Languages, has joined us. With the permission of Vice Chancellor ma'am, I would like to invite ma'am to convey her best wishes to the gathering. Swati ma'am.
Very good evening to Professor Nirmala Maurya, Vice Chancellor of Veer Bahadur Singh Purvanchal University. A very good evening to Vice Principal of Guru Nanak College, Dr. Rajshri, Learned Professor, Dr. Ram, Dr. Noor Jahan, my friend Dr. Dolly, and Dr. Manoj. Thank you very much for inviting me. I only have to say, yes, the sustainability is there in all of us mind, and we have to work together, not for only for us, but for our future generation also. भौतिक और औद्योगिक विकास के कारण हमने प्रकृति को जो नुकसान पहुंचाया है, उस नुकसान की कीमत हमारी पीढ़ी ने भुगतना शुरू कर दिया है, और मुझे ऐसा लगता है कि हमारी भावी पीढ़ी इसके नुकसान को सबसे ज्यादा भुगतेगी। उसको कम करने के लिए जरूरी है कि हम अपने तौर तरीके बदलें, अपने विकास का जो मॉडल है उसको बदलें, और ये मॉडल हमें कैसे बदलना है, इसे किस तरह से इस प्रकार का बनाया जाए कि आगे आने वाली अनेक पीढ़ियों तक प्रकृति हमें निरंतर देती रहे और हम उसका सही उपयोग करते रहें, ये जानना बहुत जरूरी है। और ये हमारे वैज्ञानिक, हमारे साइंटिस्ट हैं, वही जान सकते हैं। तो मैं बहुत बहुत नतमस्तक हूं कि इतना सुंदर विषय आप लोगों ने चुना है, और इस विषय में आप लोग आगे बढ़ रहे हैं। विद्वान जन इस विषय में बातचीत करेंगे, और निश्चित रूप से इस वर्कशॉप का हम सभी लोग फायदा उठाएंगे। मेरी बहुत बहुत शुभकामनाएं। धन्यवाद।
धन्यवाद मैम, थैंक यू। नाउ I request our Honorable Vice Chancellor Ma'am, Professor Dr. Nirmala S. Maurya, to deliver the presidential address. Ma'am.
Thank you, Dolly. Dhanyawad.
Dhanyawad, ma'am.
So, General Secretary and Correspondent of the Guru Nanak College, Mr. Manjeet Singh Nair ji, और Principal of the College, MG रघुनाथन जी जुड़ नहीं पाए, शायद कहीं बिजी हैं। वाइस प्रिंसिपल डॉक्टर जयश्री जी जुड़ी हुई हैं कहीं। डीन ऑफ साइंस गुरु नानक कॉलेज डॉक्टर नूर जहां जी दिख रही हैं। हेलो, हाउ आर यू मैम। और हमारे विश्वविद्यालय के डीन ऑफ साइंसेस प्रोफेसर राम नारायण जी। इसके अलावा नोडल ऑफिसर हैं और वर्कशॉप ऑर्गेनाइजिंग सेक्रेटरी डॉक्टर मनोज कुमार पांडे जी मंद मंद मुस्कुरा रहे हैं। वर्कशॉप ऑर्गेनाइजर एंड कोऑर्डिनेटर डॉक्टर डॉली जी, बहुत अच्छा आपका संचालन है। और सुधीर उपाध्याय जी मुझे जुड़े दिख रहे हैं। आरती रवि कृष्णन जी दिख रही हैं। और मेरे ख्याल से जो भारती रवि कृष्णन, आधा कट गया था, जो हमारे अगले सेशन की स्पीकर हैं। और सुधीर उपाध्याय जी हैं। एंड डिग्निटरीज एंड स्कॉलर्स इन द कॉन्फ्रेंस विद द कोलैबोरेशन ऑफ गुरु नानक कॉलेज चेन्नई एंड वीर बहादुर सिंह पूर्वांचल यूनिवर्सिटी जौनपुर 5 days ऑनलाइन नेशनल वर्कशॉप, जैसा कि हम सब देख रहे हैं। और यू हैव चोजन 10 स्कॉलर्स, 10 एक्सपर्ट, सब्जेक्ट एक्सपर्ट for deliver the speech. और बहुत अच्छे इसमें मैं देख पा रही हूँ, डॉक्टर भारती अभी दिखाई दे रही हैं, देन प्रोफेसर वंदना राय फ्रॉम यूनिवर्सिटी, देन डॉक्टर सुधीर कुमार जी, ही इज हियर, डॉक्टर लावण्या जी शायद वो भी जुड़ी होंगी, डॉक्टर पूनम सेठी, डॉक्टर SP तिवारी फ्रॉम पूर्वांचल यूनिवर्सिटी, प्रोफेसर राजेश शर्मा जी, मे बी ही इज हियर, आई डोंट नो, श्रीमती डॉक्टर श्रीमती
मैम
जुड़े हुए हैं, डॉक्टर नमः शिवायम, मे बी इज हियर, एंड प्रोफेसर प्रदीप कुमार जी। ये एक्सपर्ट हैं हमारे, सब्जेक्ट एक्सपर्ट। तो जितने भी डिग्निटरीज हैं, स्कॉलर्स हैं, जितने भी व्यूअर्स हैं एंड स्टूडेंट्स, आप सभी को मेरा नमस्कार। बहुत अच्छा टॉपिक है आपका, लाइफ साइंस इंटरफेस। अब हम इंटरफेस से ही गुजर रहे हैं। द की ऑफ सस्टेनेबिलिटी, इसमें दो ही चीज है आपके सामने, लाइफ साइंस और दूसरा सस्टेनेबिलिटी। यही दो मेन हमारा टॉपिक होगा 5 दिनों का के वर्कशॉप का मेन टॉपिक। उसमें आपने अलग अलग टॉपिक दिए हैं एक्सपर्ट को। और ऑलवेज वी हैव टू टॉक एट प्रेजेंट सिनेरियो। अभी स्वाति बहुत थोड़ा बोल कर गई, लेकिन बहुत अच्छा बोल कर गई। मैंने 2 चीजें ली हैं, हमारे यहाँ विद्वान बैठे हिंदी भी समझ रहे हैं। एट प्रेजेंट सिनेरियो इट्स वेरी थॉटफुल एंड डिप्लोरेबल। हम लोग 2 शब्द लेते हैं, सोचनीय एंड शोचनीय। थॉटफुल माने सोचनीय, हमारा विचार करने योग्य है। आज अब जिस सिनेरियो में हैं वो हम कैसे जी रहे हैं, हम हमारी अर्थ का, हमारी प्लेनेट का, हम जो रिसोर्सेस है, क्या हम उसका गलत प्रयोग नहीं कर रहे हैं, ये सोचने का समय है। तो सोचनीय, जिसको मैंने लिया है थॉटफुल, और शोचनीय डिप्लोरेबल, ये विचार करने योग्य है और शोचनीय है कि हम कहाँ जा रहे हैं। बिकॉज ड्यू टू आवर लाइफ स्टाइल वी आर फेसिंग लॉट ऑफ प्रॉब्लम्स। और आप सबसे ज्यादा देख रहे हैं विदिन 2 years when COVID came, we are facing lot of problems. But in that another way we can say, हमने कोविड को जो 2 साल से चल रहा है उसको हमने फेस किया, वेरी ब्रेवली वी फेस। वाई? ड्यू टू आवर लाइफ स्टाइल। जो इंडियन लाइफ स्टाइल है वो अलग है। तो मैंने यहाँ पर एक बहुत अच्छा सा एक एग्जाम्पल लिया है, क्योंकि जो ग्रीक फिलोसफर हैं 350 BC हुए हैं एरिस्टोटल, वो फादर ऑफ बायोलॉजी माने जाते हैं। ही इज द फादर ऑफ बायोलॉजी, मे बी यू कैन से लाइफ साइंस। और उनके 3 थॉट्स हैं इनके एरिस्टोटल के, थ्योरी ऑफ कम्युनिकेशन, थ्योरी ऑफ ट्रेजेडी एंड थ्योरी ऑफ कैथेरेसिस। ये जो तीनों थ्योरी है, इट्स रिलेट विद लाइफ स्टाइल। हमारा जो लाइफ स्टाइल है या हमारा जो लाइफ साइंस है, उससे ये रिलेट होता है। क्योंकि हमारा लाइफ साइंस है क्या, मैंने बहुत सुंदर लिया है उसमें, द लाइफ साइंस कंसर्न्ड विद द स्टडी ऑफ लिविंग ऑर्गेनिज्म इंक्लूडिंग बॉटनी, zoology, microbiology, physiology, biochemistry and related subjects, that is life science। और जो एरिस्टोटल हैं, ये इसी लाइफ साइंस को अपने वे में बताते हैं। जो मैंने आप 3 थॉट्स लिए यहाँ पर, कैथेरेसिस, थ्योरी ऑफ कैथेरेसिस। व्हाट इज द थ्योरी ऑफ कैथेरेसिस? फॉर आवर बॉडी वी डू योगा, जिसको हम लोग कहते हैं कि हम उसको क्या करते हैं, विलेचित करते हैं योगा के द्वारा, शुद्ध करते हैं। वी प्यूरिफाई आवर बॉडी विद योगा, विद द एक्सरसाइज, दैट इज कैथेरेसिस। जैसे उसमें नेति प्रक्रिया है, नाक में वो डालते हैं ना, एक से डाल करके दूसरे से निकालना, क्लीन करना, So many process. So he relate that thing with the medicine and with the our thoughts. वो कहते हैं कि जैसे शरीर को शुद्ध करने के लिए हम कैथेरिसिस विरेचन करते हैं, in another side our mind is there, our heart is there. So mind को क्या करना है? We should do purification. हम माइंड को, दिमाग को हमको प्यूरिफाई करना है. कैसे? करुणा से, दया से, ममता से. और क्या हटाना है? जेलसी. So many things is there. So we should do purification with the thoughts, good thoughts. ये उनका विरेचन, और ये रिलेट होता है लाइफ साइंस से. वैसे ही वो कहते हैं थ्योरी ऑफ कम्युनिकेशन. What is the theory of communication? On this dais, I am talking lot of things, but listener means you can understand what I want to say. If you understand, then communication is there. If you can't understand, then there is no communication. इसको हम लोग कहते हैं संप्रेषण का सिद्धांत. माने हम स्पीकर बोले whatever, any subject, any things, if we are talking, you are listening, but you are not reacting with that topic. So I am failure. मेरा बोलने का कोई मतलब नहीं है. क्या मैं जो बोल रही हूं, I am telling about catharesis, I am telling about life science. Are you understanding or not? If you are understand and you react, so it is theory of communication. Third one is tragedy, theory of tragedy. What is tragedy? We all are human beings. हम सारे human beings हैं. हमारे अंदर लव है, दया है, ममता है, स्नेह है, करुणा है. इसी को मिलाकर बोलते हैं ट्रेजिडी. यदि हमारे अंदर दुख नहीं है, हम किसी के दुख को समझ नहीं पाते हैं, तो हम ह्यूमन बीइंग नहीं है. वी आर नॉट ह्यूमन बीइंग. वी हैव टू अंडरस्टैंड. जैसे एक स्लोगन है, लिव एंड लेट लिव. ये क्या है? जियो और जीने दो. ये ट्रेजिडी हम जब दूसरों की समझ पाते हैं, इसे हम लाइफ साइंस से रिलेट करते हैं. क्यों? जैसे मैंने पहले कहा, एट द प्रेजेंट सिनेरियो, हम इस प्लेनेट का, इस धरती का जितना भी रिसोर्स है, चाहे वो वाटर हो, पानी हो, चाहे अग्नि हो, चाहे एनवायरमेंट हो, हम उसको कैसे यूज कर रहे हैं, और क्या हम उसको बचा कर रख पाएंगे फॉर न्यू जनरेशन. वी कैन सेव फॉर देम. दैट इज द सस्टेनेबिलिटी. क्या हम आज जो जीवन जी रहे हैं, जैसे मैंने लिया है कि यहाँ पर थोड़ा सा मैं लेना चाहूंगी, थोड़ा मैंने कोट किया है कि 2015 में यूएनओ में एक महासभा 70 महासभा में एक टारगेट लिया गया था. उसकी चर्चा भी अभी हो रही थी कि 2030 तक जो पॉपुलेशन है वो 8.3 अरब हो जाएगी. और उसमें क्या होगा कि 50% एनर्जी चाहिए, फूड चाहिए, और 30% प्योर वाटर चाहिए. क्या वो है आज? उसको हम बचा पाएंगे? हम पेड़ काट रहे हैं. आप देख रहे हैं, ड्यू टू एनवायरमेंटल डिस्टर्बेंस, कहीं बाढ़ आ रही है, कहीं बहुत पानी बरस रहा है, कहीं सूखा पड़ रहा है. तो क्या ये अच्छे साइन हैं? नहीं है. तो जो आने वाली जनरेशन है, क्या उसके लिए हम कुछ बचा कर रखेंगे? आप लोग एक स्कॉलर्स बैठे हैं, आप कई एडवर्टाइजमेंट देखिएगा, और मैंने एक रिसर्च करवाई थी एडवर्टाइजमेंट पर. उसमें एक मैं यहाँ पर जरूर उदाहरण देना चाहूंगा सस्टेनेबिलिटी के लिए. एक पेट्रोल पर विज्ञापन आता था, जिसमें गाड़ी में जाते हैं और सिग्नल पर गाड़ी चालू रहती है. तो वो जो बच्चा है वो अपने पिता से कहता है कि इंजन बंद करो, क्या हमारे लिए भविष्य के लिए कुछ नहीं बचाओगे क्या? यदि आप रिकॉल करें तो आपको जरूर याद आएगा वो एडवर्टाइजमेंट. और उसके पिताजी ऑफ कर देते हैं गाड़ी का इंजन सिग्नल पर। दैट इज वेरी बिग मैसेज कि आज हम जब कुछ बचाएंगे, वट एवर, मे बी एनर्जी, मे बी फूड, मे बी एनवायरमेंट, तो जो हम आज बचाएंगे वही नए जनरेशन को सस्टेन करेगा। यदि हम नहीं बचाएंगे तो वो कैसे सस्टेन करेंगे? दैट इज वेरी बिग क्वेश्चन। सो मैंने यहाँ पर बहुत अच्छा लिया है, जैसे हमारे यहाँ हिंदी में हम लोग कहते हैं कि मनुष्य का जो शरीर है वो बना है क्षिति जल पावक गगन समीरा। देखिए कितना हम लोगों में जो अरिस्टोटल कहते हैं और जो हम कहते हैं जो यूनानी है, यूनान और जो इंडिया है, उनके जो थॉट्स हैं बहुत मिलते जुलते हैं। तो उन्होंने जो लाइफ साइंस पर कहा, वो कहते हैं थिंग्स आर मेड अप ऑफ 5 एलिमेंट्स: अर्थ, एयर, फायर, वाटर एंड ईथर। ही इज ऑल्सो फेमस फॉर 4 causes, वो 4 रीजन भी दे रहे हैं, विच एक्सप्लेन द नेचर ऑफ चेंज इन एन ऑब्जेक्ट। टाइम टू टाइम बहुत सारी चीजें चेंज होती जाएंगी, हमको उसके साथ सस्टेन करना है। तो ऐसे बहुत सारी चीजें हैं जो सस्टेनेबिलिटी के लिए हमें चाहिए। मेरे पास बहुत सारा मैटर है बोलने के लिए, क्योंकि आज जो हम विकास करते आए हैं, जो हम कहते हैं डेवलपमेंट ऑफ सिविलाइजेशन, वो क्या है? सस्टेनेबिलिटी का ही तो एग्जाम्पल है भाई। पहले हम जंगलों में रहते थे, हमने गुफाएं बनाई, घर बनाए, खेत बनाए, खेती की, फॉर व्हाट? फॉर सस्टेनेबिलिटी। हम लोगों ने क्या खोजा? ह्यूमन सिविलाइजेशन ने क्या खोजा? एयर, फायर, अग्नि, जिस पर एनर्जी जिसको हम कहते हैं, देन लैंग्वेज, देन व्हील। ये 3 चीज हम लोग कहते हैं। इसी ने हमें क्या किया? 3 चीजें हैं, इन्होंने हमें सस्टेन किया, हमको मजबूत बनाया और हम आगे बढ़ते गए। तो रोज आप देखिए इन साइंस डेली कोई भी एक रिसर्च आ रही है, कोई भी खोज आ रही है। फॉर व्हाट? हमारे पास बहुत सारे साधन हैं, बहुत सारे संसाधन हैं, रिसोर्सेस हैं। हमें सस्टेनेबिलिटी के लिए वी हैव टू सेव दैट रिसोर्सेस। बस इन्हीं शब्दों के साथ, क्योंकि मैं बोलूंगी तो बहुत ज्यादा हो जाएगा, मैं बहुत ज्यादा लिख करके लाई थी, लेकिन मुझे लगता है कि एक्सपर्ट इस पर बोले। व्हाट इज लाइफ साइंस, व्हाट इज बायोलॉजी, व्हाट इज सस्टेनेबिलिटी, एंड एट प्रेजेंट सिचुएशन व्हाई लॉट ऑफ प्रॉब्लम्स इन फ्यूचर आफ्टर मे बी 30 years और 40 years। हम लोग मजाक करते हैं कि तब खाना नहीं रहेगा। तो एक कहानी है कि बच्चा जो है एक कंप्यूटर के आगे बैठा हुआ है एंड उसका फिगर बहुत अच्छा दिया है। आई हैव रेड दिस स्टोरी। उसका कान बहुत बड़ा बड़ा है, उसका सिर बहुत बड़ा है, बट बॉडी इज वेरी स्मॉल। एंड कंप्यूटर इज टेलिंग वन स्टोरी अबाउट civilization of humanity, civilization of human, progress of humans। क्योंकि जिस टाइम पर वो जी रहा है, भोजन नहीं है, वो कैप्सूल खाता है, पानी नहीं है, ठीक, कुछ भी नहीं है, तब उसका लाइफस्टाइल क्या है? तो ये बहुत सोचने की बात है। और ये जो 5 दिन की वर्कशॉप है, I think it's very useful for everyone and for youth also. So आप लोगों ने ये 5 दिन का वर्कशॉप किया, इसके लिए आप लोगों को बधाई हो, कॉन्ग्रेचुलेशंस और शुभकामनाएं, आशीर्वाद कि आपका कार्यक्रम चले और जहां कहीं भी मैं जुड़ पाऊंगी मैं जरूर जुड़ूंगी। इसके लिए जितना भी ये ग्रुप है उसको मैं बहुत साधुवाद देती हूँ। बहुत बहुत आभार, बहुत बहुत धन्यवाद, नमस्कार।
Thank you, ma'am. Thank you.
Thank you, ma'am. Thank you so much for all your motivation, your good words. and the blessings that you have given. I would also welcome, sorry, some of our resource people joined in a little late before I could see them, but I also welcome the resource people of other days, Dr. Sudhir, Dr. Rajesh, Vandana ma'am has also joined in. Thank you, ma'am. And I welcome, if I have missed anyone, I'm sorry, but I welcome all the resource persons.
Professor Pradeep Kumar from Veer Bahadur Singh Purvanchal Vishwavidyalaya. He has also joined since the beginning of this program.
Sorry for this because I've been admitting participants in bulk. I have not been able to see who and all is joining in. मैं अपनी अगर मैंने भूल करी है तो मैं माफी चाहूंगी क्योंकि एक साथ सब जुड़ने की कोशिश करते हैं तो वो लिस्ट मुझे दिखती नहीं, वो नीचे तक चली जाए. अभी तक जुड़ने की कोशिश कर रहे हैं और मैं डिनाई कर रही हूँ. ग्रुप में डाल दिया है, प्लीज यूट्यूब ज्वाइन हो जाइए, यहाँ फुल हो गया है. और कई बार ये होता है कि इसमें से गूगल अपने आप पार्टिसिपेंट्स को निकालने लगता है, तो इसलिए अब यहाँ पे रिक्वेस्ट मत भेजिए. आप लोग प्लीज यूट्यूब में जुड़ जाइए जो अगर सुन रहे हैं, अगर आपके दोस्त जुड़ने की कोशिश कर रहे हैं. और क्योंकि मैं कोऑर्डिनेट करती हूँ एडमिट करने में और बोलने में, तो इसलिए माफी चाहूंगी अगर मुझसे कोई छूट गया हो. आई वेलकम वन एंड ऑल. आई वुड नाउ इनवाइट डॉक्टर महेंद्र कुमार, असिस्टेंट प्रोफेसर बायोटेक्नोलॉजी डिपार्टमेंट गुरु नानक कॉलेज, टू इंट्रोड्यूस Dr. Bharti, our first resource person of the day. Sir.
Thank you very much, Dolly ma'am. It's my proud privilege to introduce Dr. Bharti Ravikrishnan, the resource person of the first session of this 5-day online workshop. Dr. Bharti Ravikrishnan is working as assistant professor and head at the Department of Biotechnology, Guru Nanak College, Autonomous Velachery, Chennai since 2007. Earlier, she worked as Assistant Professor of Biotechnology at Hindustan College of Arts and Science, Padur from 2014 to 2017, and as Assistant Professor of Biotechnology at Kumararani Meena Muttaya College of Arts and Science, Adayar, Chennai from 2006 to 2014, and as a lecturer of Biotechnology at Jaya College of Arts and Science, Tirunelveli, Tiruvallur from 2002 to 2005. Dr. Bharti Ravikrishnan completed her PhD in 2014 at Guru Nanak College under University of Madras. She passed the Tamil Nadu State Eligibility Test in the year 2016. Her technical specialization include animal cell culture, handling of industrial grade fermenter and product production, protein profiling and DNA profiling techniques, phytochemical characterization, microbial isolation and characterization, and etc. She has guided more than 40 postgraduate and 15 undergraduate student projects. She has received many awards, including the Best Paper Award in the oral presentation at the conference organized by the Department of Biochemistry, T.S. Narayanaswamy College of Arts and Science in association with the Zoological Society of India, Best Paper Award in oral presentation in the National Conference on Scientific Challenges for a Clean Environment organized by Guru Nanak College, Best Paper Award in Oral Presentation in the National Conference on Environmental Protection and Sustainability organized by the PG and Research Department of Zoology, Satyagraya College, Chennai in association with the Indian Academy of Environmental Sciences, Haridwar. She was also invited to participate and deliver a talk in the 104th Rashtriya Vigyan Sancharak Sammelan during the 104th session of the Indian Science Congress in Sri Venkateswara University, Tirupati, on the title Sustainable Development Strategies Needed for India's Future Pursuit of Happiness. She has published 16 research journals in impact journals. She has participated and presented in more than 50 conferences. Madam is a life member in the Indian Science Congress, Zoological Society of India, and OISCA, Japan. Madam, we are happy to hear from your vast experience on the topic biotechnology and inevitable technology for sustainability. Over to Dr. Bharti Ravikrishnan, Madam.
Thank you, sir. Bharti, ma'am. Before ma'am takes over the session, I request all participants to keep their mics mute and their screens off so that the streaming is smooth and the resource person is not disturbed. Thank you, Mahendra, sir. Bharti, ma'am, you can start your presentation, ma'am. Thank you.
Thank you, Dolly ma'am. Thank you, Mahendran sir, for your wonderful introduction. I would like to thank all the organizers, especially Vice Principal of Purvanchal University, Guru Nanak College, all my colleagues who are present here for listening to my speech. And I would like to thank the organizers for giving me such an opportunity to share something what is very close to my heart, that is biotechnology and its role in sustainability. I'm here today is going to share my thoughts on how biotechnology is an inevitable technology for the sustainability. So many of before also they have just mentioned that roadmap to sustainability by UNO. Yes, these are the roadmaps delivered to us by UNO. It starts right from the agriculture, reforestation, biodiversity conservation, human rights, community empowerment, climate change, emissions, water sustainability, solid waste management, and healthcare support. So these are the avenues wherein when a human being needs to be sustainable along with the biosphere, these are the avenues where we need to concentrate our research and also in all our technology development. Now, we have to have a concept of a smart city wherein we can lead a everyday life at the same time in a more sustainable and in a comfort zone. So these are all the few examples of the smart city concept wherein research we need to develop, both in technology and also in the product avenues. Now, coming to the zero waste city concept, these are few of the areas where we need to concentrate to start right from education. So unless and until we don't educate our younger generation and start involving them in research is not something that our younger generation should be doing it in a very tedious way. Small innovations, what they can bring about in all our existing technology itself is more than sufficient. We, as a faculty members, need to prepare our younger generations to face such challenges. And then we need to concentrate about the way in which the infrastructure and the thinking capacity of the society is about. And then we need to concentrate about the all the R's, that is the reduce, reuse, recycling, and recovery has to be implemented in our day-to-day life. Sustainability and consumption and the behavior of the society should also be addressed. Transformed industrial designs are needed. For example, we need to concentrate about changing the design of the car engine, which can be successfully being functioned with the help of the biofuel and not with the fossil fuel. By doing all these things, yes, there will be a great zero depletion process will be happening. The waste will be depleted, for which we need strong legislation and policies from the government side to be supportive. When we talk about the zero waste hierarchy for the sustainability, this is given by Zero Waste International Alliance in the year 2013. They say that every material must be recyclable at its best. So whatever product we are going to manufacture or we are going to use, definitely we need to have a multiple utility to all the products so that the longevity of the product will be for a longer period of time and it will not be discarded as waste in our environment. And similarly, the way in which the technologies are involved in the manufacturing of these products should also be eco-friendly. And the products, after its lifespan is over, we as a citizen, we need to concentrate about reuse, recycle, so that the amount of waste that we are generating, it will be very, very minimum and it will not affect our biosphere. Now coming to the sustainable development, there are 3 E's are there, and sustainability must bring in all the 3 E's together: social equality, economic efficiency, and environmental responsibility. Whether we are academicians or an industrialist or a researcher, all the 3 E's is what we need to concentrate upon. When we try to develop some product, we have to develop it keeping in our mind that it will be much important for our society, or any societal issues, problems can be solved. And such products, when they are being utilized at large, we can have an economic efficiency, and these products will also not result in any kind of environmental pollution. The objectives of today's industrial development must be, it must focus on an industrial technologies which is not leading to the climate change. It greatly reduces the global warming, and it should also concentrate on building up of renewable energy sector. And the sustainable products in the market must be with multi-utility purpose. And finally, by doing all this, yes, we can achieve economy, circular economy or the bio-based economy. Now, in the world, there are two types of economic are linear economy, which is concentrating upon make, and dispose. Yes, when it is the products after the usage, when it is being disposed, yes, it creates a lot of environmental hazards. And these environmental hazards finally get magnified in our human being, and we human beings are the sufferers of it. And when we see, on the other hand, the circular economy, it is a cradle-to-cradle economy where all the 3 or the 5 R's are being adapted, wherein the products are being reused, reformed, reduced, and we finally, when the products, or that is when an industrial process results in any kind of a waste, it is being reused for another product production by another industry. So by doing so, we are not only reducing the waste, we are also becoming resource efficient society. Now coming to the crux of the circular economy, the sustainable development is usually identified by having the 3 dimensions of economic, social, and environment equality. The products that are manufactured today are the resources for tomorrow at yesterday's price. By doing so, we can achieve economic, social, and environmental equality. So the main thing in the circular economy are the way in which we are going to manage the resources, reduction in the pollution, reduction in the climate change. By doing so, economic resilience is also achieved. That is, the goods are being sold to all the population at the same price, and every population will be benefited by all these sustainable products. And we need to concentrate in developing business models for sustainability. Now, coming to the concept of bioeconomic, the production of renewable biological resources and their conservation into the food, feed, bio-based products, and bioenergy. The bio-based economy refers to all economic activity derived from scientific and research activity focused on biotechnology. In other words, by understanding the mechanism and the processes at the genetic and molecular level and applying these concepts for the improving industrial technology. Let me just quote few examples over here. One is the biofuel. So by the agriculture waste, just by using the simple baker's yeast or the Saccharomyces cerevisiae, it is possible for us to produce the biofuel. By doing so, we are not only finding a solution to reduce the agriculture waste, but also by generating a very efficient economy, because the biofuel that is being produced can be used to drive the car or the bike. By doing so, we are not only saving our economy that is being spent to buy the fossil fuel, we are also reducing the pollution due to it. Another example is microorganisms, from where we can use simple waste like soybean meal or any nitrogenous waste in order to grow the microorganisms and produce wonderful products of our interest. And the processes that are involved is like a submerged fermentation or by using an industrial grade fermenter. Another concept here I would like to introduce is called as a biomimetic, where let us take a simple example of the lotus leaf. On a lotus leaf, or even a drop of water will not stay, because the angle in which the leaf hairs are pointed out is 45-degree angles. It just whatever water comes in contact with these leaf hairs, they just roll down. Along with them, they remove all the dirt and also the microbial contaminants present on the leaf. Based on this lotus leaf effect, the self-cleaning dress materials, self-cleaning shirts, bed sheets, and even paints are being developed. Now, coming to the biotechnology concept, as I've been mentioning before that, for the bio-based process economy, biotechnology is the main fundamental foundation. So the achievability of biotechnology, sustainability, and bioeconomy, we do have benefits and challenges related to this piece. Coming to the benefits, it is having a positive environmental impact, society welfare is achieved, good, sufficient, efficient technology-based solutions are being achieved, and all these products which were once being sold at a higher price is now can be sold out at a cheaper price. But the challenges involved are the ethics. Yes, too much of knowledge is also very dangerous. So it is up to the individual person who's working in an industry to understand the concepts involved and its limitations to make it to produce the product. We need suitable government policies and regulations to implement sustainability and bioeconomic in hand to hand. There are risk assessment in the technologies involved, and we need to analyze the risk at every stage, right from choosing the raw materials for our biotechnology-based product production till the product usage. And also industrial scaling up of researchers is needed, and we need a very strong intellectual property rights to be established. Biotechnology, if you see, the stakeholders are academia, governance, society, and industry. So we all need to work hand in hand. And the beneficiaries, when you're going to see, it is the health sector, food sector, agriculture, energy, and industry. Now, talking a little more about the bio-based economy, see, the material supply is very, very important for any kind of industrial product production. Since in biotechnology, we can use the waste materials of one industry, put it into the fermentation as a substrate like carbohydrate substrates or a protein substrate and grow these cells. The cells can be a bacteria, an animal, and a plant cell. So the material supply, when it comes to a bio-based or a biotechnology-based industrial product production, is much more cheaper. We just need to concentrate a bit in the design and the manufacturing process. And we need to concentrate upon pitching up of the market for all these bio-based products. And once the first life is in, it can be reused or it can be recycled. We can find a lot of multi-utility processes for the bio-based products. That is why here we create value and reduce the value that is leading to destruction. And another thing in a bio-based economy is that the circularities will be plenty, and the non-circularities which we are disposing at the end, it will be very, very minimum. And by doing so, high-value products can be produced at a very low price. In biotechnology, the main advantage is the cell itself we are using like a bigger factory. Like in an industry, how we have many employees at many segments working together for the product production. Similarly, inside the cell, we do have lots of subcellular organelles which perform their unique functions, and finally we get the functional unit of the cell as a protein. So it is the protein where we are interested in it as a product. Now, here a small input is I would like to share is that there is a concept called as wild genes are there in the cells. We are able to isolate the wild genes. We are able to isolate the modified genes from some other organisms and try to incorporate or try to understand what is the exact phenotypic character that the wild type of gene is expressing and what kind of product that the alleles are expressing. So it is possible for us to perform a genetic engineering and produce goods which are of value and which are of great demand to the general public. So here I've shown you a few examples related to the plants. One is the transgenic gene expression, which is a tissue-specific gene expression, and they're able to produce or convert the pink rose into a beautiful combination of blue and pink rose. And we can produce the biofortified food as golden rice. Yes, we can also produce cotton wherein the natural color is already incorporated. So the picture that I've shown you here is they have isolated the phycocyanin gene from the Pseudomonas aeruginosa, incorporated it into the cotton plant, and the cotton plant itself is expressing the cotton in blue color. So by doing so, we need not to concentrate or be dependent on the environmental non-eco-friendly polluting dyes. And we are also able to produce the pest-resistant crop plants by which the yield of our food resources or our cash resources can also increase. Now, in biotechnology, when we are doing all the manipulations, the only thing we need is such instruments called as a fermenter. So fermenter is nothing but an instrument which is giving us a very sterile, suitable environment which can be controlled. So two suitable environment needed for the cell to grow are like pH and the temperature, the nutrients, all the things have to be filled in a fermenter, and then we culture the respective cells, and finally we get the product of our choice. And the product, since it is produced by a living organism, the stability of the product will be very good. It is easy for us to do the purification and the formulation process, and this can be used by the society at large. A few examples here I would like to quote is, we can use bacterial cells, algal cells, fungal cells, grow them in a fermenter and produce varieties of products what we are really in need of. Like the whole organism, the cell itself can be consumed like a probiotic. From these organisms, we can isolate the enzymes, which can be having much demand in the food industry, in the medicine, in the therapeutic agent preparations, and also in the pollution degradation process. We can also have the metabolites like an alkaloid, which can be used as an antimicrobial or agents. We can get growth factors. We can get pigments. The pigments, if I would like to add upon a point, these pigments, food, people choose food, for example, a cake based on the color and the flavor. So far the color and the flavor used by by the local bakers, they are all chemical based, and they have found a lot of toxic effects that could be result by the consumption of these colorful toxic chemicals and flavors. Instead of that, we can just choose the microorganisms which is producing a specific pigment or the specific color and use it in the food production. And coming to the field of biotechnologies, yes, we have got varieties of biotechnology based on the application. So the red biotechnology is where we produce a lot of therapeutic related agents and also diagnostic kits. Green biotechnology, wherein we produce pesticide resistant plants or plants having a good yield like the biofortified plants. And next comes the industrial biotechnology, which is the white biotechnology. We produce a lot of enzymes, the phytochemicals by using microbial cells or a plant cell or an animal cell. And next comes is the brown biotechnology, which is nothing but the aided biotechnology, wherein any animal or any life form, when it is present in a very bad condition, for example, microorganism present in a sewage, it tries to adapt to its environment. This is the adaptability which we are interested in, and this is the adaptability which we are able to derive it as a product and use that for the human survival or any life form survival. So in case of an arid biotechnology, plants are able to survive in the desert area. That means they've got some protective gene within them, which is going to help that particular animal or a plant to survive in a very dry arid segment. So we can isolate these genes, incorporate it into our crop plants and make the crop plants to survive in limited water, or when the salt concentration is going to be more also, it will be able to survive. So such plants are called as the drought resistant plants. So in India recently also for many years, they have trying to develop the drought resistant rice plants. Normally rice needs some amount of water, some level of water to be stagnant, only then the growth can be achieved. But by producing the drought-resistant rice plants, it is possible for us to grow the rice plants even in an arid region. So we are increasing our productivity. And we can incorporate genes like beta-carotene into these rice plants and increase the beta-carotene. So once a person consumes the beta-carotene in his liver, it is converted into lycopene, and lycopene is in turn converted into vitamin A. So in India, there is a big issue of malnutrition of the vitamin A is existing. So by producing such rice varieties, it is possible for us to address such issues of malnutrition also. Next comes the blue biotechnology. As we are there in Chennai, we have a longest coastline, and many researchers are happening at the coastline, both at the algal level, microbial level, and also for the sea animals. And the next comes is the biofarming. So when we are involving the microorganisms or a plant or an animal to produce the therapeutic agents or diagnostic agents or any health supplements, the concept is the biofarming. So all that we need to do is just screen for the cell or a microbial cell or a plant cell or an animal cell, which has got the capacity to produce the product in which we are interested in. And we need to standardize the medium. We need to understand the conditions in which the cells are able to grow and also able to produce our product. But by doing so, we just need to put the cells, formulate a medium, and set the conditions for a fermentor, culture these cells, and we are going to get the products in the form of primary metabolites or in the secondary metabolites. A few examples here I would like to mention is about the animal biotechnology, wherein it is possible for us to produce the compounds which the society is having a nutritional imbalance. So by producing such biofortified animals, yes, this problem, we are able to address the problem of the society. For example, Suguna is one of the egg production unit at Salem at Tamil Nadu. They are producing the eggs with brain supplements like DHA, vitamin D, improved eggs. So these kind of nutritional benefit eggs are also being produced. And such nutrients, when they are produced chemically, we need to concentrate upon storing these chemicals and also doing the formulation, wherein the cost is being involved. But when we produce such biomolecules inside an egg as such, the shelf life will be much more higher. So it is possible for us to store these kind of biomolecules inside an egg very easy. So the cost involved in the storage process of the biomolecules can also be reduced. The next comes is the personalized medicine. This is not a very new concept to our entire world, especially a country like in India, because all our the medications or the therapeutic analysis, they are all based on the personalized analysis only, based on the heat that the body generates, like an example. So people understand what is the problem inside the body and they try to sort it out. Now we are able to do that little bit scientifically with the help of biotechnology techniques. So we are able to understand what kind of phytochemical, when delivered into the body, the phytochemical acts like a cell signal or an inducer of a cell process by which the processes which are being suppressed inside the cell, now they are getting activated. So the cellular function is restored, the tissue function is restored. It is simple to address or solve the disease existing in our society. And another thing is that is precision diagnosis. We are able to exactly understand what is the problem that the person is having, what kind of physiological imbalance the person is experiencing with, and it is possible for us to store that particular physiological imbalance, and thus the person is getting treated. And now next comes is the health security. Initially, when we are developing any kind of medicine, we need to undergo, drug testing. It's a very huge process. We need to get the bioethical clearance. To maintain the lab animals is also quite difficult. And there are a lot of ethical issues are also being involved. But nowadays, whenever you find out any kind of a therapeutic agent, we just have something called as a chip, a cell on the chip. It's shown over here. So here the cells are being aligned into it and the blood is being circulated within the cell. So whenever you want to do a drug testing, you see the effect, the cytotoxic effect on the particular cell and also the other body cells also. Like what will be the effect of that particular drug on a heart cell, on a kidney cell, liver cell. So whatever specific organ we want, the cell functions we want to test, all those cells can be implanted into this particular biochip and allow the drug to pass through within the bloodstream. And we can, once the spent blood comes out, by analyzing the spent blood, we can understand whether the drug is having any toxic effect to the other body cells or not. So there is a capacity of health security present when you are involving the technologies of biotechnology. So whatever drugs we are developing, it is very easy for us to test, and we can also formulate the drugs as the requirement of the patient. We do have a much more advanced animal biotechnology, that is the 3D tissue and the organ culture and printing. So nowadays we are able to print the skin, cells, tissues, and it is easy for us to treat skin burn patients or diabetic wound related patients. And next comes is the concept of the green biotechnology or the agriculture biotechnology. The agriculture waste can be used for the production of biofuel, biomaterials, and also the biochemical products or the biopolymers, which can be used in varieties of industrial purposes. Yes, fuel is one of our big constraints. Nowadays, everywhere in India, the fuel price is also increasing. It's a high time we start concentrating in understanding how to convert the agriculture waste into the biofuel. Whenever we are using the biofuel, only thing we need to concentrate here is we need to redesign a bit of our engine. When we talk about a country like Brazil, in 1965, along with India, Brazil also started its industrial revolution, but then in 1965, the Brazil's economy was based only upon the usage or the selling of the drugs or the casinos. But now if you are able to see, Brazil has hosted even Olympics also. The only thing is all the agriculture waste, especially the corn waste, they have converted into the biofuel, redesigned the engine model of the car or the two-wheelers to suit the function of the biofuel. By doing so, even in a country like in India, there are very few researchers with the biofuel are there, but many such researchers related to biofuel has to come up, because India is an agriculture country and we do have a lot of agriculture waste like sugarcane or the paddy straw waste. So all the things can be converted into the biofuel, and we need mechanical engineers to remodel the engines of the car or the two-wheelers so that it can run very efficiently with the biofuel. Toyota, Mercedes, they have even launched their sports car in events with this running with the biofuel. And the next concept that is related to biotechnology that is involved in the product production is biomimetics. We need not to do a very hardcore research in the product production. We can, on the other hand, we can just understand the nature that is surrounding us. Nature is our best teacher. So we can understand how things function in the nature, try to understand the mechanisms, and try to incorporate it into the product production. There are many such examples based on the biomimetic products are being manufactured. To mention a few is the bullet train from Japan, which is having the hood of the front engine of the particular bullet train. It is in the shape of a kingfisher beak. So a kingfisher is a small bird with a small head, but when it's diving into the water to catch the fish, it dives at 90 degrees angle. At that speed with which the kingfisher is diving into the water, the head of the kingfisher can be bursted by the air friction. But doesn't happen because the beak is long and pointed, which is able to cut the streamline motion of the air, and it is able to split the air, and the air is not having much friction over the bird's head. So based on this biomimetic concept, the bullet train head is being developed, which is able to travel with a very high speed. And another example is what we use in our home day to day, the toothpaste tube. The toothpaste, once it was coming in an aluminium pack, so to squeeze out the last drop of toothpaste, it will be very, very hard. But now the inner lining of the toothpaste or all our oil packets is being manufactured from the concept of the pitcher plant. The pitcher plant is an insectivorous plant, and the inner lining is having nanofibers, which will allow the insects to slide within it and drop into the enzymatic fluid. and the insect body is completely digested. The protein is absorbed by the pitcher plant cells, and the body waste is being thrown out. So similarly, how the nanofibers are arranged inside the pitcher plant nowadays, even in our biodegradable oil packet or the toothpaste or any squeezable tube, it is of the same biomaterial, by the same nanomaterial. So it is easy for us to use the product without any wastage. Another concept like I would like to discuss is an aquaponics or an hydroponics. Japan is one country wherein doesn't have much of the soil, or the existing soil is not having a very fertile in nature. So the hydroponics have been developed to grow certain plants which can derive the nutrients from the liquid nutrients, whatever is supplied to the plant, and the plant is going to grow. Nowadays, along with this hydroponics, aquaponics is also being incorporated, because all the fish waste or the crustacean waste can be, which is nitrogenous rich in nature, can be taken up by these plants, and the plants can grow, and these plants are very much good in having the biofortified compounds. And next comes is the environmental pollution. Here, India imports 50,000 of e-waste and generates around 350,000 tons of e-waste. This is a picture of the aerial view of Chota Nagpur Plateau. And we can see over here that in the year 1880, India is having a good forest cover. And because of the mining process, this is a picture at 2010, where we can see there is a lot of depletion in the forest cover area. And worldwide also nowadays, a lot of earthquakes are also happening. This is because of the shift in the topography, and the shift in the topographic plane is happening because of the lack of the vegetation. And this is a picture of the Chota Nagpur Plateau, and we can see here the majority of the area which is barren, and you can see very, very limited vegetation being present over here. So all these issues, how it is possible for us to address this through biotechnology. So it is one example that I would like to mention here is that is, in all our integrated circuit system, we do have gold. So gold acts like a good conductor that cannot corrode on its own or undergo combustion on its own. So normally gold in IC gadgets is being used as a switch contact, or it is used in the printed circuit board. So once these electronic e-gadgets lifespan is over, we can just crush these the IC circuit boards, put it into a suitable medium, allow the organism like Aspergillus niger to grow. So Aspergillus niger is going to release all the gold from this integrated circuit. By doing or by adapting to such bioleaching or a bio-ore concept, it is possible for us to 100% have the reusage or the recirculation of the e-gadgets. And e-gadgets are a good source of lots of metals like aluminum, arsenic, antimony, barium, beryllium, zinc, tin, silica, selenium, silver. So all these kind of metals that we use in our day-to-day gadgets manufacturing can be got from the discarded gadgets itself. But the only thing is we need to understand which is the specific microorganism that is degrading and releasing all these precious metals for our product manufacturer. And these are few examples that I would like to also mention about the eco-friendly products here. So here Adidas is a shoe manufacturing company which is manufacturing the shoes from the plastic waste that has been extracted from the sea. And there is a lot of reports stating that the plastic that are discarded in the ocean, they themselves form an island, and it is creating a huge loss to the aquatic life forms. But Adidas has come up with a concept of collecting all these plastic waste, converting that into fine threads, and with the threads, jogging shoes are being manufactured. And also another thing like I would like to quote is plastics are being converted in many places into the plastic bricks which are made to lay the roads or the pavement. And next comes is the this thing which I found it to be recently very innovative, which is a straw that is being manufactured from the coconut discarded leaves. This is developed by Professor Saji Verghese. And then comes the concept of edible plates, which are being manufactured from the sugarcane waste or from the plantain waste. And then we also have the sanitary pads, which are manufactured from the water hyacinth. Water hyacinth has got a good cellulose concentration, and it has got a capacity to have an absorption also. So with this, sanitary pads are being manufactured. And next comes is the bioenzyme, which can be used as a shampoo or the utensils cleanser. This is being obtained from the orange peel waste. And these are all other few of the eco-friendly products that we can manufacture. And in our department of biotechnology at Guru Nanak College, along with Guru Nanak Center for Innovation, Incubation, Entrepreneurship and Startups, we are manufacturing a lot of products like hand sanitizer, organic soap, essential oils have been extracted from the orange peel waste. Mosquito repellents are also made with all the organic materials that are present within our college campus. And with the essential oil, extracted essential oil, we do make a lip balm. We produce 2 lip balms. One is the fruity one, and another one is the orange-based lip balm. And we also produce bio-waste product as the hand wash, which we prepare it from all the citrus peel waste. And to provide the soapiness, we are using the soap nut extract. And next comes is the organic fertilizer. So here we are using the onion peel waste, banana peel waste, and the tea peel waste as a source of phosphorus, potassium, and nitrogen. And we are growing the fenugreek. Next comes is the biodegradable sanitary napkin. Yes, we have an exclusive unit installed in our college. I would like to thank our General Secretary and Advisor ma'am to support in all our initiatives. And we are producing the sanitary napkin with herbal incorporation. So the herbal part that is present in this sanitary napkin is gunkra stem base, turmeric, aloe vera gel. Finally, when we have so much of products that can be manufactured by biotechnology, we need to concentrate upon developing the suitable business models also. All the business models that are existing at present in our market, they are all based on or supporting only the linear economy. It's the high time we start shifting towards the business model which supports these kind of bio-based products. Bio-based products, yes, at times they are being sold at a very high price because of the low demand. But when we are able to do the correct marketing of it, we will be able to increase the product production and thereby reducing the cost of the selling cost. So these reasonings implies that the companies can reduce the negative impact on the environment because in a bio-based economy, the raw materials are the waste of one industry. Now, I would like to just add upon a bit of academics into this also. When we need to concentrate on biotechnology as an inevitable technology for sustainability, we need to teach our students with this specific importance. When we see about our students whom we are getting today, or who are even many of the students are even attending the sessions, they do not come to us just to develop the career. They come to us with their curiosity. They want to know why certain things are happening, how the certain things are happening. So the game changer to teach biotechnology is we need to trigger the curiosity of the students. We need to teach them the mechanisms, but make them to understand it in their own mindset. And biotechnology is a true concept that supports social, governance, economic, commerce. That is why all the concepts, how much ever possible, we need to incorporate it into our curriculum. Now, learning biotechnology, it involves starting from the teaching. It is our teacher's role to teach the correct concepts, the correct mechanisms to the students, and give them a lot of participatory and analytical skill development related activities so that they are able to understand when they study a concept, what they can do with the concept, like what kind of a product can be developed. And then they have the cognitive learning. They will definitely have the research and innovation coming up into their thought process. And once they are having the brainstorming sessions, the students, they will come up with new products or new technologies. By adapting to such curriculum, we support the students to have a career diversification. If a student is not able to be successful in one career, definitely they will be having a plan B by which they can have a career diversification and they can face the challenges in the field in a very strong and an ethical way. And they will be definitely successful in their career. Knowledge is one of the support for growth of creativity. In today's scenario, we need creativity, we need innovations so that we can achieve true sustainability. Building knowledge or cognitive structure in the first and foremost important thing that must be provided to the learners first before improving their creative skills. The two phases of learning biotechnology, these are just my suggestions. First phase is strengthening of conceptual learning, then motivating them towards the constructive learning paradigm where students build their own knowledge. In the phase two, in this phase, students must be encouraged to build creative thinking skills, followed by exhibiting their creative products. In our department, we do conduct something called as a junk art so that students are being motivated to identify what are the possible wastes that are surrounding them and what kind of products that can be made out of it. Because the main foundation for biotechnology is fermentation technology, wherein we are using waste of one industry as a suitable raw material or a nutrient source for the cells to grow. Example, bagazi, which is a good source of carbohydrate, is used for the production of many of the pharmaceutical important products like medicines, antibiotics, and also the biogas. In the phase 3 of teaching biotechnology, we have to concentrate on in supporting the students for the problem identification, research innovation, and sustainable products or technologies so that whatever product we are able to produce, so when the people are able to use that, waste is not generated and we can have a true sustainable biosphere. When it comes to an academic model of curricular circular economy for economic resilience, the 5 things are, we need to concentrate on right from the starting of what is circular economy, the comparison between circular and linear economy. The coming to the second part is the circular economy principles and practices, wherein we need to concentrate upon the concepts of zero waste. Then comes the business value in the circular economy, wherein we have to teach the children about developing business models and marketing strategies. Next comes the circular economy opportunities in India. So here, definitely as academicians, we also need the government support, because once we have some initiatives being given to the children, definitely they'll come up with lots of bio-based products. And we also need to continuously keep discussing with them about the existing case studies at global level, at national level, and also at the regional level. It is right time to set the curriculum pedagogy towards sustainability and circular economy, for which the principles of biotechnology will be very, very useful. The role of biotechnology is it is connecting people, justice, dignity, partnership, and the planet. Biotechnology leads to conservation, generations of bioresources for economic development. By adapting to this, yes, we not only increase our GDP, we can also increase our national gross happiness. The road to the circular economy may be very narrow, winding, but the travel is worth it. It leads to sustainability. I would like to end my session with a quote by Steve Jobs: "Stay hunger, stay foolish." When as an academicians or researchers or a student, when we try to find a problem surrounding us, yes, it is our duty to understand why the problem is existing, and then we have to understand what kind of technologies to be developed or a product to be developed so that the problem can be addressed. And by doing so, the society at large will be at benefit. Thank you.
Thank you so much, ma'am. It was a very colorful and a very clear, crisp presentation, which was also self-explanatory also, ma'am. So thank you so much. Participants? The session is open for questions. If you have any, you can discuss. You can either ask the questions now, or we can also have an open session at the end of both the sessions together. Even Vandana ma'am would be joining that time. So are there any questions from the participants?
बेटा लास्ट में रखो, ज्यादा ठीक है, बीच में डिस्टर्ब होगा अभी, दोनों का एक साथ कर लो.
Okay ma'am. Okay. So we can have the question answer sessions, the open session at the end of both the sessions. I would request Dr. Mahendra Kumar sir once again to introduce our resource person for session 2, Dr. Vandana Rai. Mahendra Kumar sir.
Yes, ma'am. I thank Dolly ma'am for giving me this opportunity. I was just going through Professor Vandana Rai ma'am's profile. I could not actually concise it. It was so elaborate, and it's a very vast experience which I could see in her profile. I had tried my level best to concise for time. So, madam, I'm very happy to introduce you. Professor Vandana Rai is working as Dean and Professor at the Department of Biotechnology, Veer Bahadur Singh Purvanchal University, Janpur, Uttar Pradesh. Madam started her career at Veer Bahadur Singh Purvanchal University as lecturer in 2000, became senior lecturer in 2004, promoted to the post of reader in 2009, and then to the post of associate professor in 2012, and as professor in 2015. Professor Vandana Rai completed her PhD in zoology with specialization in cytogenetics on the title Cytogenetics of Sarcophagidae under the supervision of Professor Deepika Kaul from the reputed University of Allahabad. Professor Rai has held various administrative positions as Dean, Faculty of Sciences, Head Department of Biotechnology, Microbiology, Biochemistry, Environmental Sciences during the same stint at VBS Purvanchal University, and also as Chairperson, Internal Compliance Committee, Women's Cell, etc. Madam has also served as member of many academic bodies at VBS Purvanchal University, and to name a few, member Executive Council, Academic Council, Internal Quality Assurance Cell, Admission Committee, Examination Committee, and the list goes on. Professor Rai has received and handled research projects worth more than 60 lakhs from leading funding agencies like the UGC, DBT, DST, CSIR, ICMR, etc. Madam has also organized more than 20 conferences and workshops with financial assistance from agencies like ICMR, DST, Government of India, etc. Madam has published more than 100 research articles in international and national reputed journals with very high impact factor. Madam has published 4 books on recent advances in biotechnology and cancer cytogenetics, and has also authored more than 15 book chapters in various book series. Professor Vandana Rai is the recipient of many reputed awards, and to list a few, the I2OR Distinguished Researcher Award 2018 for remarkable contribution in the field of human molecular genetics, IARDO Award for Lifetime Achievement 2018 by International Association of Research and Development Organization in 2018, Best Teacher Award by the Lions Club of Janpur in 2009, Best Poster Award at the National Seminar on Biotechnology and Health Prospects and Perspective in 21st Century at ITM University, Gwalior in 2010. Professor Vandana Rai has participated and presented papers in more than 50 conferences and submitted more than 100 abstracts. Professor Rai has served as the International Scientific Committee member for the 20th International Conference on Domestic Animals and Cytogenetics held in Paris, France in 2018, and for the 19th International Conference on Neonatal and Perinatal Medicine held in Sydney, Australia in 2017. Professor Rai is a member on the editorial board and also a reviewer of many leading journals like Molecular Biology Reports, Indian Journal of Biochemistry and Biophysics, Indian Journal of Medical Research, PLOS ONE, International Journal of Genetics and Molecular Biology, International Journal of Applied and Basic Medical Research, International Journal of Clinical Biochemistry, etc. She is a lifetime member in many reputed international and national scientific bodies like the very famous Indian Academy of Neurosciences, Biotech Research Society of India, Indian Society of Human Genetics, Indian Women Scientists Association, Indian Science Congress Association, Indian Society of Cell Biology, All India Congress of Cell Biology and Genetics, Indian Association of Cancer Research, International Society of Applied Biology. Madam, we are very happy to hear from your vast experience on the topic biotechnology, folic acid and women's health, and inevitable for today's current scenario. Over to Madam.
Thank you, Mahendra Kumar sir. Thank you so much. Hearing this itself was really very, I don't have words for
Ma'am,
it.
I promise I have done just 25% of Madam's resume.
I know, I've seen her resume even in the last workshop, so I know you have just taken a part of it. Ma'am, with all your vast experience, ma'am, we are actually blessed to have you here for this workshop, and thank you for taking out time to join us. So, ma'am, you can please go ahead with your presentation, ma'am. Vandana, ma'am.
Ma'am, your voice is not coming.
Ma'am, unmute कर लीजिए, please.
हेलो, आवाज नहीं आ रही आपकी.
वंदना मैम की उनका म्यूट हट चुका है. मैम, आपकी आवाज नहीं आ रही है. वंदना मैम, your presentation is on the screen but we cannot hear you. सिस्टम वॉल्यूम ऊपर करिए मैम. शायद सिस्टम वॉल्यूम आपका कम होगा मेरे ख्याल से. स्पीकर वॉल्यूम आपके सिस्टम का.
मैम, हमें लगता है जो ईयरफोन आप इस्तेमाल कर रही हैं उसमें कुछ प्रॉब्लम है सारे स्पीकर्स.
नहीं,
Ma'am, I think you can remove the
हेडफोन्स मैम. आप हेडफोन्स निकाल दीजिए मैम. आई थिंक आप उसके बिना बोल लेंगे.
Now you have to unmute.
अभी अनम्यूट करिए. हाँ, अनम्यूट योरसेल्फ मैम. नहीं, आपने अनम्यूट नहीं करा है. सिस्टम म्यूट पे है आपका.
मैम, आपका अनम्यूट करिएगा.
Yes, ma'am.
Yes,
Now you are audible. No, again you gone muted.
मैम, आप म्यूट हो गए हो. आपके स्क्रीन पे अनम्यूट का ऑप्शन होगा. माइक का सिंबल होगा, उससे अनम्यूट करिए प्लीज. आवाज नहीं आ रही है मैम. आवाज नहीं आ रही है. Technology has connected us, but of course we have the backdraws of it, the boons and the bans. I request the participants to please kindly bear a little with us. Ma'am will be back.
हेलो
जी मैम.
आवाज आ रही है?
जी मैम, आ रही है मैम.
ओके, सॉरी फॉर द इनकन्वीनियंस.
मैम, आपका प्रेजेंटेशन लेकिन अभी
मैं आप कर रही हूँ
जी.
स्टार्ट कर रही हूँ.
Yes ma'am, visible.
Visible?
Yes ma'am.
Okay.
मैम, इफ पॉसिबल वीडियोस अपना ऑन कर देंगे.
है? वीडियो तो ऑन कर रही हूँ.
ठीक है.
Yes ma'am. अब सब है.
But I am unable to see my presentation.
We are able to see your presentation, but
Okay.
मैम आपको अपना स्क्रीन मिनिमाइज करना पड़ेगा. आप गूगल मीट को नहीं देख पाओगे. आप सिर्फ अपना प्रेजेंटेशन ऑन करिए.
Okay. Okay. Yes. Sorry, ma'am. Okay. Now it's visible and
Yes,
I'm
ma'am.
audible. Okay. Thank you very much. Good afternoon to all of you. I'm Vandana Rai from Department of Biotechnology, VPS Purvanchal University, Jaunpur. First of all, I would like to thank the organizing
Ma'am,
committee.
excuse me, ma'am.
Yeah, pardon.
Could you please make it the slideshow, ma'am?
Okay. It's visible? Hello?
It's visible. Just press F5.
मैंने दबा दिया F5. I have just pressed F5. Is it visible?
No, ma'am. Full screen is not visible.
It is still in the slide mode only, ma'am. Slide show नहीं शुरू हुआ है.
Yes.
Yes, ma'am.
It's okay?
Yes, ma'am.
Okay. Thank
Perfect.
you very much. First of all, I would like to thank the organizing committee, especially Dr. Dolly and Dr. Manoj Pandey, for giving me this opportunity to present my opinion in front of you in the 5-day national online workshop, Life Science Interface, the Key to Sustainability. I would like to thank our Vice Chancellor, Professor Nirmala S. Maurya ji, जिनके कंटिन्यूअस इंकरेजमेंट के कारण हम लोग लगातार डिफरेंट इंस्टीट्यूट से MOU कर रहे हैं और हम लोगों को इस तरह की फैसिलिटीज मिल रही हैं कि हम लोग जॉइंटली कोई ना कोई कॉन्फ्रेंस या वर्कशॉप या FDPs कर रहे हैं. तो मैम, एक बार आपको बहुत बहुत धन्यवाद कि आप इस पूर्वांचल यूनिवर्सिटी में आई और आपने यहाँ पे एक पॉजिटिविटी फैला दी. साथ ही साथ I would like to thank the officials of Guru Nanak College for giving me this opportunity. Thank you very much. Now, my title of the presentation is Folic Acid and Women Health. The title of workshop is the Life Science Interface, the Key to Sustainability. So the first question arises, what is sustainable development or sustainability? According to UNO definition, the sustainable development has been defined as development that meets the needs of the present without compromising the ability of future generation to meet their own needs. UNO has given 17 sustainable developmental goals to transform our world or globe. And as we all know, I think most of us are aware that our visionary Rashtra Pita Mahatma Gandhi has said that there is enough for everybody's need and not for everybody's greed. तो हम सब human जो एनिमल है, मैं तो एनिमल ही कहती हूँ, being a zoologist and being a biotechnologist, we the animals are very greedy and हम लोग जो है एक्सप्लॉयटेशन करते हैं, यूज नहीं करते. अगर हम सारे अपने रिसोर्सेज को यूज करें, एक्सप्लॉयट न करें, तो सस्टेनेबिलिटी बनी रहेगी हमारे फ्यूचर जनरेशन के लिए और कोई भी क्राइसिस कभी भी नहीं आएगी. 17 sustainable development goals में the third one is related to health issues. The third goal is ensure healthy lives and promote well-being for all at all ages. So my main emphasis is on goal 3. Now I came to some facts of WHO. As according to WHO, 6.2 million children and adolescents under the age of 15 years die, and 5.3 million deaths occurred in the first 5 years. Similarly, the maternal health is also, the condition of maternal health is very poor, especially in African Asian continent. Every day, approximately 810 women die from preventable causes related to pregnancy and childbirth. And out of these, 94% of all maternal deaths occur in low and lower middle income countries. In 2021, the Secretary General of UNO said in Food System Summit that there should be inclusive and transformative food system, nourish progress to achieve zero hunger. He discussed about the zero hunger conditions in future. And so rich or poor, young or old, every person in the world needs to eat. And according to this subject, the Action Track 1 also ensures access to safe and nutritious food for all. Achieving the goal means increasing the availability of nutritious food, making food more affordable, and reducing inequities in access to food. So, with all these backgrounds, I have chosen the topic which is very much related to my research interest, that is folic acid and women health. First of all, I will discuss about the folate. What is folate? Folate is a natural compound which is found in leafy vegetables and fruits. And in general term, folate is used to describe different forms of vitamin 9, like dihydrofolate, tetrahydrofolate, 5,10-methylate, etc. And during cooking, in the cooking or processing, the folate is lost. So the efficacy of folate absorption is also only 50%. If we take 200 micrograms, only about 100 micrograms are actually used by the body. Second term which is used along with folic acid, folate is folic acid. Folic acid is the synthetic oxidized and stable form of folate, and which is used for food fortification as nutritional supplement. Folic acid जो है वो synthetic form होता है folate का, और इसको जो है ये टैबलेट फॉर्म में या कैप्सूल फॉर्म में मिलता है, जिसको कि फूड फोर्टिफिकेशन में यूज किया जाता है. Folic acid discovery, the credit goes to discovery of folic acid credit goes to Lucy Wills, who is an English hematologist and physician. She conducted research in India in late 1920s and early 1930s on macrocytic anemia. Macrocytic anemia is a anemic condition during pregnancy in which the size of red blood cells is enlarged and the frequency of RBC is also very reduced. And this anemia is the main reason behind the death of the pregnant ladies in India. Wills discovered the nutritional factor in yeast that both prevents and cures this disorder, and after her name, this factor is known as Wills factor. How in 1941 scientists have isolated this factor from spinach and named it as folic acid, because in Latin folium means a leaf. Spinach, this folic acid is isolated from the leaf of spinach और पालक से इसको आइसोलेट किया गया था. तो लैटिन में फोलियम मीन्स अ लीफ, पत्ती होता है, तो इसलिए इसको फोलिक एसिड का नॉमेनक्लेचर दिया गया. Folate rich foods जो हैं, these are several vegetables and oranges are rich in folate or folic acid. And for example, like broccoli, beans, papaya, oranges, lentils, दालों में भी बहुत ज़्यादा folic acid होता है, spinach, पालक. तो ये सारे जो फूड्स हैं ये सब के सब रिच फूड्स हैं. Now what are the metabolic roles or functions of this folate or folic acid? Basically, folate is essential for DNA synthesis, DNA, RNA, histone, lipid, and protein methylation. It's essential for proper chromosome segregation during cell division, and also essential for normal gene expression. Its deficiency has been associated with abnormal DNA methylation, abnormal gene expression, abnormal chromosome segregation during cell division, and DNA strand breaks. The groups which are at risk for folate inadequacy or deficiency are people who with alcohol use disorder, the persons who regularly take alcohol, they are at risk for folate deficiency because alcohol interferes in the absorption of folic acid or folate. Second risk group is women of childbearing age, that is pregnant ladies. The requirement of folic acid is just double for pregnant ladies in comparison to normal women. In addition, the people who are suffering for some malabsorptive disorders such as celiac disease or irritable bowel disease. And fourth one, which is the most important, is the individuals with MTHFR polymorphism. MTHFR, I will discuss it later in my presentation. The symptoms of folic acid deficiency is the fatigue, gray hair, mouth sores, swollen tongue, forgetfulness, depression, lost appetite, concentration, trouble in concentration, several birth defects, as well as poor growth. Now come to MTHFR. MTHFR is the full form. MTHFR is methylene tetrahydrofolate reductase. It is an enzyme which is a critical for folate pathway. The folate which we actually human cannot synthesize folate, और हमको इसको अपनी डाइट में लेना पड़ता है. That's why it is very important to take green leaves and fruits. After entering into the cell, folate is converted into 5,10-methylene tetrahydrofolate, and this 5,10-methylene tetrahydrofolate is converted into 5-methyl tetrahydrofolate, and this reaction is catalyzed by an enzyme which is named as methylene tetrahydrofolate reductase. The 5-methylene tetrahydrofolate is a methyl donor. Actually, थोड़ा सा केमिस्ट्री है जो समझने में प्रॉब्लम होगी नॉन साइंस बैकग्राउंड के लोगों को, लेकिन बेसिकली जो ये फोलेट है, इसका मेन एम ये है कि एक मिथाइल ग्रुप डोनेट करता है होमोसिस्टीन. होमोसिस्टीन इज एन सल्फर कंटेनिंग अमाइनो एसिड. ये सल्फर वाला एक अमाइनो एसिड होता है. अमाइनो एसिड्स क्या होते हैं आप सबको पता है, जिससे कि प्रोटीन्स बनते हैं. तो होमोसिस्टीन जो है वो भी हमारी बॉडी में ही सिंथेसाइज होता है, और हायर कंसंट्रेशन ऑफ होमोसिस्टीन जो है वो सेल्स के लिए बहुत टॉक्सिक होता है. तो सेल में कंटिन्यूअसली ये होमोसिस्टीन का मेटाबॉलिज्म होता रहता है और ये डिग्रेड होता रहता है, कन्वर्ट होता रहता है मेथियोनिन में. तो होमोसिस्टीन को मेथियोनिन में कन्वर्ट करने के लिए एक मिथाइल ग्रुप की जरूरत होती है, और वो मिथाइल ग्रुप जो है वो डोनेट करता है ये 5-methyl tetrahydrofolate. मेथियोनिन जो है वो क्या करता है कि फिर कन्वर्ट होता है एस एडेनोसिल मेथियोनिन में, और मेथियोनिन जो है, जब हमने आपको फोलेट के लिए इसेंशियल फंक्शंस में बताया था मिथाइलेशन, डीएनए सिंथेसिस, तो मिथाइलेशन जो एक प्रोसीजर है उसके लिए मिथाइल ग्रुप ये एस एडेनोसिल मेथियोनिन ही डोनेट करता है. तो ये सेलुलर मिथाइल डोनर होता है जो कि सारे जितने भी मैक्रोमोलिक्यूल्स हैं, प्रोटीन, डीएनए, लिपिड, इन सब का मिथाइलेशन जो है ये सेल ही करता है. तो इन शॉर्ट ये फोलेट जो है ये सेल के मेटाबॉलिज्म के लिए बहुत ज़रूरी है, क्योंकि ये सेल में जाने के बाद डीएनए सिंथेसिस, मतलब डीएनए जो होता है उसके जो प्रिकर्सर होते हैं थायमीन, साइटोसिन, गुआनिन, इन सब की सिंथेसिस करता है। साथ ही साथ वो जो जीन है उसके एक्सप्रेशन को कंट्रोल करता है थ्रू मिथाइलेशन। ये पूरी प्रोसीजर होती है। तो इसलिए अगर फोलेट डेफिशिएंसी होगी तो इंडिविजुअल जो है उसमें डीएनए सिंथेसिस जो है वो स्लो हो जाएगा, उसमें जीन एक्सप्रेशन जो है वो एबनॉर्मल हो जाएगा। इसलिए फोलेट नॉर्मल सेलुलर मेटाबॉलिज्म, सेलुलर फंक्शन के लिए बहुत ज़रूरी है, फोलिक एसिड और फोलेट। साथ ही साथ जो MTHFR है ये नॉर्मल कन्वर्जन तो करता है 5,10 मिथाइलिन टेट्राहाइड्रोफोलेट को 5 मिथाइल टेट्राहाइड्रोफोलेट में, लेकिन ये जो एंजाइम है इसका भी एक जीन होता है ह्यूमन जीनोम में, हमारे जीनोम में। और ये जीन जो है, थोड़ा सा बैकग्राउंड जेनेटिक का होना ज़रूरी है कि हर प्रोटीन के लिए एक जीन हमारे सेल में प्रेजेंट होता है जो कि न्यूक्लियस में होता है, और वो ट्रांसक्रिप्शन ट्रांसलेशन के बाद वो प्रोटीन बनाता है। जैसे हमने इस फोटोग्राफ में इन दिस इज द क्रोमोसोम 1 at 36.22 position, MTHFR gene is located, and which after translation encode the MTHFR enzyme. Several single nucleotide polymorphism is reported in this gene, and one which is very much clinically important is C677T polymorphism. ये polymorphism क्या होता है कि ये कोई abnormality नहीं होती, mutation नहीं होता बेसिकली कि इसके रहने से आदमी बीमार हो जाएगा, लेकिन इसके नॉर्मल जो हम सब हैं, जो नॉर्मल है उनके में ये C होगा, लेकिन जो म्यूटेंट होंगे उनमें इस C की जगह T होगा। तो इस C और T के सब्स्टिट्यूशन की वजह से जो MTHFR प्रोटीन होता है उसमें 222 पोजीशन पे, 222nd पोजीशन पे एलेनिन की जगह वेलिन अमाइनो एसिड आ जाता है। ये एक अमाइनो एसिड चेंज होने की वजह से जो MTHFR एंजाइम है, ये जो MTHFR एंजाइम है, इसकी एक्टिविटी रिड्यूस हो जाती है, और इसकी एक्टिविटी जब रिड्यूस होती है तो ये इस कन्वर्जन को एफिशिएंटली नहीं कर पाता। मतलब 5,10 मिथाइलिन टेट्राहाइड्रोफोलेट जो है वो एफिशिएंटली 5 मिथाइलिन टेट्राहाइड्रोफोलेट में कन्वर्ट नहीं हो पाता, और जिसकी वजह से ये होमोसिस्टीन जो है वो एफिशिएंटली मेथियोनिन में नहीं कन्वर्ट होता, और सेल में प्लाज्मा में होमोसिस्टीन एक्यूमुलेट होने लगता है, और इसको कहते हैं हाइपर होमोसिस्टीनीमिया, जो कि बहुत ज़्यादा चीज़ों के लिए रिस्क फैक्टर है, स्पेशली कार्डियोवास्कुलर डिजीजेस के लिए। ये वही स्लाइड है जिसको कि मैंने अभी एक्सप्लेन्ड। दिस इज अ डायग्राम शोइंग द एग्जाम्पल ऑफ सिंगल न्यूक्लियोटाइड पॉलीमॉर्फिज्म इन MTHFR gene. With this prior knowledge, in our laboratory we have collected blood samples and analyzed the MTHFR C6 polymorphism in 1000 subjects, and we calculated the frequency of T allele. This one T जो है वो इसका म्यूटेंट एलील है, तो T एलील की फ्रीक्वेंसी हमने डिटरमाइन की इस ईस्टर्न यूपी पॉपुलेशन में, और जो कि हम करीब 11% है। और अपने लैब के रिसर्च करने के बाद वी हैव जस्ट कंपेयर्ड इट विद द ग्लोबल फ्रीक्वेंसी, एंड वी हैव पब्लिश्ड दिस paper in a very reputed journal IGCV, and in addition we have also reported in 3 or 4 papers again in the Indian Journal of Human Genetics, Indian Journal of Medical Sciences, etc. The symptoms of MTHFR mutation are similar to folate deficiency: fatigue, brain fog, anxiety, depression, insomnia, migraines or headache, and chronic pain in joints and muscles, and as well as obesity. This slide shows the association between MTHFR, C6 polymorphism, and disease risk. C6-770 MTHFR polymorphism is a risk factor for congenital defects, for cancer, for psychiatric disorders, for reproductive disorders, neurodegenerative disorders. First of all, I will discuss about the anemia risk. Latest in 2019, National Family Health Survey, according to National Family Health Survey, the 68.4% of Indian children and 66.4 women were anemic, and as anemia causes 20% of maternal death in India and also causes low birth weight among babies. During pregnancy or delivery जो maternal deaths होती हैं उसका main reason है anemia. That's why इसी वजह से iron fortification and folic acid fortification जो है वो start हुआ कि during pregnancy जो है iron tablets and folic acid tablets जो है वो pregnant ladies को दिया जाने लगा. Low level of folic acid can cause megaloblastic anemia. With this condition, red blood cells are megaloblastic anemia. Lucy Wills ने जिसको report किया था, reported in 1930s, early 1930s. That is megaloblastic or microcytic anemia, in which the size of RBC is enlarged and as well as the number of RBC cells is reduced, and the lifespan is also reduced. Second major defects which are the folate deficiency causes the major defect which is congenital defects, which is the group of defects known as congenital or birth defects. And the term congenital defect refers to all abnormalities of structure or function, including metabolism, which are present since birth. 7.9 million births with serious birth defects due to genetic or partial genetic causes occur. हर साल 7.9 million बच्चे पैदा होते हैं जो कि congenital defect के साथ होते हैं. हम सबको सुनाई पड़ता है कि कुछ बच्चे पैदा हुए जिनका पैर नहीं था, जिनका हाथ नहीं था, हाथ में 6 उंगलियां थी, अलग अलग कहीं पे फोड़ा था, सर में फोड़ा था, कहीं ना कहीं इस तरह की abnormalities. These are all known as congenital defects or birth defects. In India, the prevalence rate of congenital malformation or birth defect is 19.4 per 1,000 birth. And the commonest birth defects are neural tube defect, orofacial cleft, congenital heart defects, and Down syndrome, etc. The neural tube defect is the most common and as well as serious birth defect, and with the prevalence of 1 per 1,000 live birth. And its results due to the failure of neural tube to close during neurulation in 21 to 28 embryo. Actually, जब fetus womb में यूट्रस में डेवलप होता है तो सेकेंड वीक में कुछ सेल्स जो है वो डॉर्सल साइड में अरेंज हो जाती हैं और वो एक न्यूरल ट्यूब बनाती हैं. ये न्यूरल ट्यूब जो है वो फ्यूचर सेंट्रल नर्वस सिस्टम हमारा बनाता है, ब्रेन और स्पाइनल कॉर्ड. ये जो न्यूरल ट्यूब है इसके एंटीरियर एंड एंड पोस्टीरियर एंड पे जो है ये ओपन होती है, लेकिन ऑन 28th डे ऑफ क्या कहते हैं एम्ब्रियोनिक डे ये एंटीरियर एंड पोस्टीरियर जो साइड है ये क्लोज हो जाती है. अगर फोलिक एसिड का जो डेफिशिएंसी होती है तो ये न्यूरल ट्यूब्स जो हैं ये क्लोज नहीं होती है और ये डेवलप होता है एंटीरियर में, जिसे कहते हैं न्यूरल ट्यूब डिफेक्ट. अगर पोस्टीरियर एंड में ये जो न्यूरल ट्यूब है ये क्लोज नहीं होती तो इस कंडीशन को कहते हैं स्पाइना बाइफिडा, और जो चाइल्ड होता है वो बर्थ के समय उसके स्पाइनल कॉर्ड पे नीचे की तरफ पोस्टीरियर साइड में एक ट्यूमर लाइक स्ट्रक्चर होता है. इसी तरह अगर एंटीरियर एंड पे ये नहीं क्लोज होता है न्यूरल ट्यूब तो इसको कहते हैं इंसिफेलो और इंसिफेलो विदाउट ब्रेन। इस तरह के की बर्थ बच्चे जो है इस तरह के स्ट्रक्चर के साथ उनकी बर्थ होती है। तो इन आवर लेबोरेटरी वी हैव एनालाइज्ड about 42 subjects in which we have found a very strong and significant association with OR of 5.83 in homozygote model। हमने जो है ऐसी मदर्स के ब्लड सैंपल्स को लिया जिनके बच्चे एनटीडी के साथ पैदा हुए थे। एनटीडी मतलब न्यूरल ट्यूब डिफेक्ट के पेशेंट्स थे। इन बच्चों इन मदर्स का ब्लड सैंपल लिया, साथ ही साथ हमने जो है कंट्रोल्स जिनके बच्चे हेल्दी थे उन मदर्स को लिया और कंपैरिजन करने के बाद ये रिजल्ट आया कि जो ऐसे मदर्स जिनमें MTHFR C677T पॉलीमॉर्फिज्म है उनमें हाई रिस्क होता है कि उनके जो बच्चे हों उनको एनटीडी या न्यूरल ट्यूब डिफेक्ट हो। और इसको हम लोगों ने एक वी हैव पब्लिश्ड दिस फाइंडिंग इन अ वेरी प्रेस्टिजियस जर्नल नेम्ड मेटाबॉलिक ब्रेन डिजीज एंड द मेन रीजन बिहाइंड द NTD is the disruption of cellular nucleotide synthesis and cell proliferation due to folate deficiency. The nucleotide synthesis hampered and as well as cell proliferation hampered. Simultaneously, the histone and DNA methylation is abnormal and hyper homocystinuria or homocystinemia is the main cause behind the embryonic neuroepithelium disruption. Second commonest birth defect is cleft lip and palate. हम सब लोगों ने इस तरह के बच्चों से कभी ना कभी देखा होगा इस तरह के बच्चों को। और I think in 2010 a small film स्माइली ट्रेन जिसको कि जो है बहुत ज़्यादा अवार्ड्स मिले थे, वो डॉक्टर हैं डॉक्टर सुबोध सिंह जिन्होंने इंडिया में सबसे ज़्यादा क्लेफ्ट लिप पैलेट की सर्जरी की है थी, उस पे वो पिक्चर बेस्ड थी। एंड दिस कंडीशन इज नॉट लीथल बट इट्स हाईली प्रिवेलेंट एंड प्रिवेलेंट रेट जो है वो 1 in 300 to 2000 बर्थ लाइव बर्थ में से एक बच्चे को इस तरह की प्रॉब्लम होती है। Actually, the folic acid or folate are essential for the DNA synthesis, DNA methylation, and cell division and tissue growth. और ये सारी की सारी प्रोसेसेस जो होती हैं नॉर्मल फीटल डेवलपमेंट के लिए बहुत ज़रूरी होती है। जब फीटस जो है वो डेवलप हो रहा होता है तो कंटिन्यूअसली उसमें जो फीटस है उसमें बहुत ज़्यादा हाई रेट पे सेल डिवीजन होता है। और सेल डिवीजन होने के लिए ज़रूरी है कि जो डीएनए कंटेंट है वो जस्ट डबल हो हर सेल डिवीजन में। तो डीएनए सिंथेसिस का रेट भी हाई होता है, डीएनए डिवीजन का रेट भी हाई होता है, एज वेल एज डीएनए मिथाइलेशन भी जो है वो ज़्यादा होता है, क्योंकि बहुत सारे जीन्स जो हैं उनका एक्सप्रेशन होता है, वो शट ऑन होते हैं, शट ऑफ होते हैं, इस तरह की प्रोसीजर्स लगातार होती रहती है। तो एक ये प्रॉपर कंसंट्रेशन ऑफ फोलिक एसिड बहुत ज़रूरी होता है। अगर वो इसकी इनएडिक्वेसी होती है तो इस तरह के कंजेनाइटल डिफेक्ट्स आते हैं, फीटस में दिखाई पड़ते हैं। इसका भी हम लोगों ने इन आवर लेबोरेटरी वी हैव एनालाइज्ड CLP केसेस and controls, and we found a very significant strong association with the dominant model with the odds ratio 2.88, and we have published our results in 3 journals, reputed journals like IJCB and academic journals. Third congenital defect is Down syndrome. It's the commonest case of mental retardation, and it results due to the trisomy of chromosome 21 with prevalence rate of 1 DS per 700 live birth. And symptoms of Down syndrome are mental retardation, the IQ इनका सही नहीं होता है, mentally retarded होते हैं, narrow eye opening, up slanting, eye eyebrows, and flat nose, These are all symptoms of Down syndrome. In these patients, there are trisomy of chromosome 21. And we have, unfortunately, we have analyzed the DX cases, and we didn't find any significant association. But when we analyze the maternal MTHFR, and we find a significant association with OR with 1.49 OR, and we published this result in PLOS journal, PLOS 1. Next class of disease is diseases or disorders related to brain, like neurological or mental or psychiatric disorders. Actually, homocysteine, higher concentration of homocysteine is toxic for cell, and in cell the homocysteine is metabolized by 3 processes. First one is transmethylation, which I have discussed. Second one is transsulfuration, and third one is betaine pathway. In normal, in all body cells, these all 3 processes are functional, but in brain cells or neurons, the enzymes for transsulfuration and betaine pathway are absent. So in brain cells only homocysteines are metabolized through transmethylation processes. So the neurons are most susceptible towards the hyperconcentration of homocysteine. Depression and women. The next disease which is I want to discuss is depression. Approximately 280 million people worldwide have depression, and according to WHO, the burden of depression is 50% higher for females than males, and Indians are reported to be among the world's most depressed population. Or the prevalence rate of depression in India ranges from 1.5 per 1,000 to 37.74 per 1,000 individuals, and the majority of these depression people are in last culminated into the suicide, successful suicide. So the in the suicide rate is also highest in India, especially in teenagers. And we published 2 papers in cellular and molecular biology, and we reported very significant and strong association between MTHFR, polymorphism, and depression. Several mechanisms are reported for neurotoxicity by homocysteine, higher concentration of homocysteine. First one is the impaired methylation. Second one is the excitotoxicity. Higher concentration of homocysteine activate the NMDA receptors, which leads to increased neural injury. And third one is due to the hyperhomocysteinemia, the oxidation stress is increased. And third one is that the higher concentration of homocysteine damages the endothelial lining of CNS, central nervous system, and causes ischemia or hypoxia. The Alzheimer disease is the 4th leading cause of death globally, and it's the neurodegenerative, progressive neurodegenerative disorder, and the main hallmark of this disease is the presence of amyloid beta plaques between the neurons and the presence of neurofibrillary tangles inside the neurons. Several risk factors are reported, but the gender is the main risk factor. And in total AD worldwide total patients, 65% AD patients are female, whereas only 35% are male. In India, more than 400 million people are suffering from Alzheimer's disease, and only 10% of cases are diagnosed. It is expected to be doubled by 2030. So the Alzheimer, the females are we have published 2 articles in Molecular Neurobiology and IGCB, and global strong association of MTHFR C6776 with Alzheimer's disease we have reported. And basically folate deficiency induces several pathophysiological changes in the brain, and just like it induces the mitochondrial dysfunction leading to oxidative stress. It reduces the calcium regulation and impaired the neural and synaptic transmission, and accumulate hyperphosphorylated tau as well as beta amyloid plaques. Now I come to the women reproductive health and its relationship with folate and MTHFR gene polymorphism. Reproductive health refers to the condition of female reproductive system during all life stages, and the reproductive system is made of organs and hormone producing glands, including ovary and the pituitary gland. Reproductive disorders affects millions of women globally, and the commonest reproductive health problems are polycystic ovary syndrome or PCOD, recurrent pregnancy loss or idiopathic abortions, endometriosis, uterine fibroids, and gynecological cancers such as cervical, ovarian, and uterine cancer. The polycystic ovary syndrome or PCOS or PCOD is the most common, and with the prevalence of 2 to 25% of women of reproductive age. It is characterized by hyperandrogenism, that is, it secretes higher amount of androgen, and amenorrhea and oligonuria. It is associated with the increased risk of pregnancy loss, and also it is the risk factor. PCOD is a risk factor for obesity, type 2 diabetes, hypertension, and dyslipidemia. It is a heterogeneous condition, and environmental as well as genetic factors play an important role in PCOD and PCOS. According to Rotterdam Consensus Diagnostic Criteria, minimum 2 symptoms of the following should be present. First one is clinical hyperandrogenism, second one is oligonucleation, and third one is polycystic ovaries. We have analyzed the MTHFR gene in PCOS or PCOD patients, and this paper is in correspondence, and we found a significant association, that is individual or women with MTHFR C6770 polymorphism have higher risk of PCOD. Next is recurrent pregnancy loss. The recurrent pregnancy loss or spontaneous abortion is defined as 3 or more consecutive miscarriages. If अगर किसी एक women को continuous without any known reason, बिना किसी जाने रीजन की वजह से बार बार मिसकैरेज होता है, तो उसको कहते हैं रिकरेंट प्रेगनेंसी लॉस या स्पॉन्टेनियस अबॉर्शन और इडियोपैथिक अबॉर्शन. और ऑल ओवर वर्ल्ड अराउंड अप्रॉक्सीमेटली 1 to 5% ऑफ कपल्स जो हैं वो इस प्रॉब्लम से को फेस कर रहे हैं. एंड दिस द रिकरेंस ऑफ अबॉर्शन इंक्रीजेस विद द मैटरनल एज and the number of successive losses. We analyzed the cases of 102 cases of RPL and 119 controls, and we reported our finding in 2 journals, IGCB and CMB, and we found a highly significant association with odd ratio 1.35 in allele contrast and 1.95 in homozygote comparison. Folate function as methyl donor as well as it involves in the synthesis of precursor for involves in the synthesis of DNA precursor. So the dysregulation of folate metabolic pathway due to the either due to the deficiency of folate of MTHFR-C6 polymer could result in carcinogenesis. We analyzed the 50 cases of breast cancer and 50 cases of controls, and we found a very good and strong association with 1.62 odd ratio. And we published this into the very prestigious journal Metagene and Asian Journal of Preventive Cancer Prevention and Therapeutics. The ovarian cancer is a silent killer because the young girls, they ignore the abdominal pain, and early diagnosis may saves life. In Asian Pacific Islands, the frequency is 9.1 per 1,000. It's a silent killer, and when we analyze the MTHFR-C670 polymorphism in ovarian cancer cases, we do not find any significant association. This is the first negative result we reported. Now, basically there are 2 important mechanisms by which folate deficiency or MTHFR-C770 polymorphism may influence or increase the cancer risk. Actually, 2 classes of genes are responsible for carcinogenesis. One is tumor suppressor gene and second one is oncogene. ऑन्कोजीन्स जो है वो हमारे जीनोम में इनएक्टिव फॉर्म में प्रेजेंट होते हैं, और ड्यूरिंग लाइफ टाइम किसी वजह से, चाहे इन्वायरमेंटल फैक्टर हो चाहे और कोई फैक्टर हो, ये प्रोटो ऑन्कोजीन्स जो है वो ऑन्कोजीन में कन्वर्ट हो जाते हैं, तो उस इंडिविजुअल को कैंसर हो जाता है, कार्सिनोजेनेसिस प्रोसेस जो है वो स्टार्ट हो जाती है. लेकिन अगर उस इंडिविजुअल में ट्यूमर सप्रेसर जीन जो है वो नॉर्मल होते हैं तो उस ट्यूमर को सप्रेस कर देते हैं और इंडिविजुअल जो है नॉर्मल होता है. तो दोनों टाइप ऑफ जीन्स जब डिफेक्टिव होते हैं तभी कोई किसी इंडिविजुअल में कैंसर होता है. तो जो मैकेनिज्म है जिससे MTHFR-C6 पॉलीमॉर्फिज्म और फोलेट डेफिशिएंसी जो है वो इंक्रीज करता है कैंसर रिस्क. फर्स्ट वन इज बाय इंड्यूसिंग मिस इनकॉर्पोरेशन ऑफ यूरेसिल इनटू डीएनए. डीएनए में जो नाइट्रोजनस बेस होते हैं वो 4 होते हैं, एडेनिन, गुआनिन, साइटोसिन एंड थायमिन, जबकि मैसेंजर आरएनए में जो है थायमिन की जगह यूरेसिल होता है. तो फोलेट डेफिशिएंसी की वजह से या MTHFR पॉलीमॉर्फिज्म की वजह से डीएनए में यूरेसिल जो है वो जुड़ जाता है, उसका इनकॉर्पोरेशन हो जाता है. और हमारा जो सिस्टम है वो बहुत ही एक्यूरेट सिस्टम होता है, प्रूफ रीडिंग होती है उसमें, और जब प्रूफ रीडिंग होती है तो वहां से जो डीएनए है वो ब्रेक कर जाता है, और डीएनए ब्रेक करने की वजह से म्यूटेशन होता है, और इस म्यूटेशन की वजह से कैंसर होता है. या फिर सेकंड जो मैकेनिज्म है उसमें ये है कि जो प्रोटो ऑन्कोजीन जो कि हमारे सेल में एज इनएक्टिव इनएक्टिव फॉर्म में प्रेजेंट रहता है तो फोलेट की डेफिशिएंसी या MTHFR पॉलीमॉर्फिज्म की वजह से मिथाइलेशन कम होने की वजह से जो प्रोटो ऑन्कोजीन्स हैं वो एक्टिव हो जाते हैं और एक्टिव होने की वजह से वो उनका एक्सप्रेशन स्टार्ट हो जाता है, वो जीन जो है वो एक्सप्रेस होने लगते हैं और फिर जो है वो कैंसर हो जाता है। मतलब ये कि हाइपोमिथाइलेशन की वजह से प्रोटो ऑन्कोजीन्स जो है वो ऑन्कोजीन में कन्वर्ट होते हैं जिसकी वजह से कैंसर होता है। तो ये दो मेजर मैकेनिज्म्स हैं जिसकी वजह से कैंसर होता है। 1992 में ही US Public Health Services recommended that all women with at reproductive ages should consume 400 microgram of folic acid daily. 1992 में US की जो पब्लिक हेल्थ सर्विस एजेंसी थी उसने रिकमेंड कर दिया कि जो भी प्रेग्नेंट लेडीज हैं उनको डेली 400 माइक्रोग्राम फोलिक एसिड कंज्यूम करना चाहिए। और 1998 में USA एंड कनाडा ने फोलिक एसिड फोर्टिफिकेशन स्टार्ट कर दिया था फ्लोर में। इसके बाद जो है 81 कंट्रीज जो हैं उनको फॉलो करते हुए इन्होंने भी बीट फोलिक एसिड फोर्टिफिकेशन इन बीट फ्लोर में स्टार्ट कर दिया। लेकिन बट टिल 2017 यूके जो है वो उसने फोर्टिफिकेशन फोलिक एसिड फोर्टिफिकेशन स्टार्ट नहीं किया था, लेकिन कंटिन्यूअस इंक्रीजिंग फ्रीक्वेंसी ऑफ कंजेनाइटल डिफेक्ट्स एंड कैंसर, उन्होंने एक कमेटी कॉन्स्टिट्यूट की जिसका नाम था साइंटिफिक एडवाइजरी कमेटी ऑन न्यूट्रिशन SACN, और उनको कहा कि आप जो है इसको जज करिए कि फोर्टिफिकेशन करना चाहिए या नहीं करना चाहिए। कमेटी ने जो है साइंटिफिक एडवाइजरी कमेटी ने रिपोर्ट किया कि फोर्टिफिकेशन जो है फोलिक एसिड को जो है वो फ्लोर में ऐड करना चाहिए, और ये न्यूज़ जो है यूके में बहुत हाइप की गई। और इस साइंटिफिक एडवाइजरी कमेटी ऑन न्यूट्रिशन जो थी SACN, इन्होंने अपने रिकमेंडेशन में हमारी लैब के 4 आर्टिकल्स को साइट किया, जो कि हम लोग के लिए एक बहुत ही गर्व का विषय है। तो इंडिया से पूरे ये सिर्फ यही 4 आर्टिकल्स जो हैं वो साइट किए गए थे। अब ग्लोबल के बाद इंडियन सिनेरियो क्या है कि नेशनल पायलट प्रोग्राम ऑन कंट्रोल ऑफ माइक्रोन्यूट्रिएंट एंड malnutrition estimated that daily intake of folic acid in rural areas of various Indian states ranged between 75 microgram and 167.7 microgram, which is far lower than the 400 microgram necessary to prevent birth defects. एक नॉर्मल इंडिविजुअल को जो है 400 माइक्रोग्राम रिप्रोडक्टिव एज की जो विमेन है उसको 400 माइक्रोग्राम जो है वो फोलिक एसिड की ज़रूरत होती है बर्थ डिफेक्ट को प्रिवेंट करने के लिए। लेकिन हमारे इंडियन सिनेरियो में कंडीशंस ये हैं कि 75 माइक्रोग्राम से लेके 167 माइक्रोग्राम ही खाली हमको हमारे यहाँ की जो रिप्रोडक्टिव एज वाली वीमेंस हैं उनके में कंसंट्रेशन ये पाया गया, जो कि बहुत ही लो है। देन इन सब चीज़ों के बाद FSSAI ने जो है रिकमेंड किया फोलिक एसिड फोर्टिफिकेशन, और एट प्रेजेंट जो है हमारे यहाँ फ्लोर जो है वीट फ्लोर वो फोर्टिफाइड वीट फ्लोर जो है वो मार्केट में आ गया है, जिसको कि फोर्टिफाई किया गया है आयरन, फोलिक एसिड एंड विटामिन B12। बहुत सारे फोर्टिफाइड फूड्स जो है मार्केट में अवेलेबल हैं। इन सारे बैकग्राउंड के साथ साथ हम लैब रिसर्च के साथ साथ जब हम लोगों ने ये जाना कि या इस एरिया में जो कि हम एक्चुअली आवर यूनिवर्सिटी इज लोकेटेड इन द रूरल एरिया ऑफ जौनपुर सिटी, सो इन सारी चीज़ों के बैकग्राउंड सबको देखते हुए हम लोगों ने स्टार्ट किया अपने लैबमेट्स के साथ। मैंने अवेयरनेस प्रोग्राम ऑर्गेनाइज करना स्टार्ट किया नियर बाय नेबरिंग विलेजेस में, और बहुत सारे करीब 13-14 अवेयरनेस प्रोग्राम्स रेगुलरली हम लोगों ने उस समय ऑर्गेनाइज किए। कॉलेजेस में जाके, इंटरमीडिएट कॉलेजेस में जाके जो यंग लड़कियां हैं उनको बताया कि आप जो है इस तरह से फोलिक एसिड लें। तो यहाँ पे मैं अपनी बात ख़त्म करती हूँ और कि जो है और इस ऑब्जेक्टिव के साथ हमने अपनी पूरी रिसर्च की कि जो मदर है हमारी फ्यूचर मदर और जो मदर्स हैं प्रेजेंटली वीमेन हैं वो सारी की सारी हेल्दी हों। थैंक यू वेरी मच।
थैंक यू मैम। बहुत ही इंफॉर्मेटिव, बहुत ही क्रिस्प प्रेजेंटेशन मैम। Thank you so much. Participants, the session is open for questions. If any of you have any questions, kindly post it in the chat box. You can directly ask the resource person also. People who are on YouTube and listening, you can post your questions in the chat box there. They will be read out here. Are there any questions? कोई कुछ पूछना चाहेगा या कुछ भी?
Good afternoon, ma'am. Ma'am, thank you for this wonderful presentation, madam. Thank you for creating this awareness, ma'am. Ma'am, from my side, I have a doubt. How to balance the iron and calcium level, madam? When we take calcium, this iron level goes down. And so how to balance this naturally through diet?
वंदना मैम, आपके लिए क्वेश्चन है मैम।
एक्चुअली मैम आयरन कैल्शियम एब्जॉर्प्शन जो है वो ओनली 30, जितना भी कैल्शियम हम लोग लेते हैं ओनली 30% कैल्शियम इज एब्जॉर्ब बाय टाइम। सो वी हैव टू इंक्रीज आवर कैल्शियम इनटेक एंड इट्स अ really very serious condition when iron and calcium both are मतलब क्या कहना चाहिए, दोनों के दोनों अगर इनका अमाउंट कम है तो इसको बैलेंस करने के लिए आप जो है जो आयरन की टैबलेट्स आती है, मैं आपको एक एग्जांपल देती हूँ. एक्चुअली माय मदर इज सफरिंग फ्रॉम एनीमिया एंड ही इज एट द एज ऑफ आई थिंक 75. तो उनको कोई भी आयरन टैबलेट दिया जाता था तो वो डायरिया कर देता था, तो जिसकी वजह से हम लोग बहुत परेशान थे. तो जो गवर्नमेंट एक छोटी सी टैबलेट यहाँ पे सारे ब्लॉक्स में देती है इन एनीमिया के लिए, तो वो जो आयरन का वो एक्चुअली फेरस फॉर्म होता है शायद, जहाँ तक मुझे याद आ रहा है. एक फेरस एंड फेरिक, तो फेरस फॉर्म होता है वो डाइजेस्ट हो जाता है, एंड जो फेरिक आयरन होता है वो डाइजेस्ट नहीं होता, वो कॉज करता है डायरिया. आई एम लिटिल कंफ्यूज्ड, कुछ बहुत पुरानी बात है, मुझे याद नहीं आ रहा है, लेकिन अगर आप फेरस फॉर्म लेंगे वो बहुत ही छोटी टैबलेट्स होती हैं तो वो डायरिया कॉज नहीं करती, लेकिन वैसे आयरन लेंगे तो वो प्रॉब्लम करता है. तो आप अगर फेरस लें और साथ ही साथ हाई इनटेक जैसे 500 का जो है कैल्शियम लें, तब थोड़ा बहुत बैलेंस पॉसिबल है, जो कि मैं खुद कर रही हूँ, इस चीज को फॉलो कर रही हूँ. दैट्स राइट.
थैंक यू मैडम. थैंक यू.
Thank you, ma'am. Any more questions?
Live, get lost. Live YouTube here, man.
Bharti, ma'am, you have something to say?
No, ma'am. It was a great opportunity, ma'am.
Okay, thank you. Your mic was unmute, so I thought you were discussing something. Okay. I guess there are no more questions for today. Since it's the first day, probably the participants are yet catching on to the concept of sustainability. Sorry. So the concept of sustainability, as Noorjahan ma'am also explained and Ramnarayan sir also explained, it is something new, which is we have been dealing with it with different nomenclatures, but I think now the official terminology being sustainability, people are still catching on to it. So thank you for introducing such a theme, Noorjahan ma'am. And I think it would help all of us to understand more about what actually, how do we relate sciences also with sustainability. It's not just anything else, but also not just ecosystem or anything, but it also sciences, everyday life we deal with it. So thank you so much, ma'am. I would like to thank General Secretary Sir. He was unable to join us today. Mr. Manjit Singh Nair, our advisor ma'am, Dr. Merlin Morris ma'am, our principal sir, who is officially on a travel today, so he expressed his inability to join us, Dr. M.G. Raghunathan ji, and our vice principal ma'am, Dr. N.C. Rajashri ma'am, and above all, our honorable vice chancellor ma'am, who took out the time to be with us during the session. She sat through almost the entire session, and Dr. Nirmala S. Maurya ji.
अभी भी हूँ.
Okay, she's still with us. So, ma'am, taking out so much time from your busy schedule and staying throughout our session to motivate us, to bless us. Thank you so much, ma'am. And the resource persons for today, Dr. Bharti and Professor Vandana Rai, ma'am. It was wonderful hearing so much expertise from you. The opening sessions have been so great. So, I just hope we continue the same way for the next 4 days. Participants, the feedback link will be given to you shortly. I'll be posting it in the chat box. And also for YouTube users, the feedback link will be posted in the live chat box. Please take it from there. It will not be emailed to you. It will not be given to you in the WhatsApp group. Kindly fill the feedback form every day to get your overall certificate at the end of the 5th day. So tomorrow's session, we'll be meeting up at the same time at 3 o'clock for the introduction and then the session. If I can, I will give you a brief about tomorrow's session is 3 o'clock. The first session is going to be held by, Dr. Sudhir K. Upadhyay ji, Assistant Professor, Environmental Sciences, Veer Bahadur Singh Purvanchal University. And second session is going to be handled by Dr. Lavanya, Assistant Professor, Biotechnology, GNC. So we'll be starting at the same time at 3 o'clock, followed by both the sessions, 3:30 to 4:30 and 4:30 to 5:30. I thank all of you present here, but it would be wrong if I do not thank my counterpart though, Manoj sir. Dr. Manoj.
Thank you, ma'am. Yes, ma'am. Thank you, ma'am.
आज सर भी कहीं बिजी थे, लेकिन हमारे साथ जुड़े रहे, अपने काम को चलते हुए हमसे जुड़े रहे. थैंक यू सो मच सर. आपके सपोर्ट के बिना तो कार्यशाला हो ही नहीं सकती है. So I thank my nodal officer from the other end, Dr. Manoj Kumar Pandey ji, for all his support. He has been on calls with me till 11, 12, 1 o'clock in the night, and he keeps pushing me to do things much faster. So thank you, sir. I thank all of you present here once again. And any comments, anything, you can speak now, or you can start filling up the feedback form. You can check for the feedback form in the chat box. Vice Chancellor ma'am, अगर आपकी permission है, तो can we end the session?
Permitted, but जरूर.
Thank you, ma'am. Thank you, ma'am. Satish sir, you can close the live, sir, and you can post the feedback link in the live chat, sir, first.
Thank you all.
Thank you so much, Noorja ma'am. Thank you so much. Thank you, Ram Narayan sir, अगर आप हैं यहाँ पे तो.
Thank you, madam. Thank you.
Thank you so much, sir. Thank you, धन्यवाद, sir. The feedback link is in the chat box. Kindly you can check the feedback link. Satish sir, kindly post the feedback link in YouTube also.
Thank you, ma'am.
Thank you so much, Bharti ma'am. Thank you for joining us.
Thank you, all of you.